Hello there, and welcome. Tonight I want to take you somewhere, not to a place you can find on any map, but to a space that exists in the quiet moments just before sleep, a place of gentle wonder and peaceful curiosity. So find a comfortable position. Let your body feel heavy, supported, and still. Allow your breathing to find its own slow, easy rhythm, a quiet tide rising and falling. There is nothing for you to do, nothing to solve. All that is required is to listen and to let your mind drift with my voice. Tonight we're going on a journey to the edge of our solar system and back again. We're going to follow a silent traveller, a visitor from the great cold darkness. We are going to contemplate a mystery that begins with a faint smudge of light in an astronomer's telescope and ends in the deepest questions we can ask. Our story begins with an object named 3 Atlas. It doesn't sound like much, does it? A designation, a series of letters and numbers. It sounds clinical, distant, unpoetic. It's a name given by the Asteroid Terrestrial Impact Last Alert System, a survey designed to find objects that might come near our world. But a name is just a label, a convenient file folder for a story that is almost incomprehensibly old and grand. Let us, for our journey tonight, give it another name. Let's call it the Wanderer. This wanderer, 3 Atlas, was first noticed in the final days of 2019. A tiny, faint blur moving slowly against the fixed tapestry of the stars. To the computers and the astronomers watching, it was another discovery, another data point to be logged and tracked. But what they were seeing was not the beginning of a journey. It was the end of one, or perhaps just the middle. Imagine, if you will, a place so far from the sun that our star is just one of many bright points of light in the sky. A place of profound cold, a silence that has lasted for billions of years. This is the realm of the Oort cloud, a theoretical sphere of trillions of icy bodies that surrounds our solar system like a vast ghostly shell. It is the deep freeze of our solar system's history, and it is from here, from this unimaginable reservoir of cosmic quiet, that the Wanderer began its journey. We don't know what started it. Perhaps the gentle gravitational nudge of a passing star, a star that itself was just moving through the galaxy on its own billion-year path. Or maybe a subtle gravitational resonance, a ripple in the fabric of space-time was all it took. A tiny push, imperceptible, but enough. Enough to dislodge this one particular piece of ice and rock from its ancient stable orbit and send it on a new path. A path that would lead it, after millions of years of falling into the inner solar system, towards us, towards the sun. Think of it. For eons the Wanderer existed in a state of near-perfect stillness, in a darkness so complete it is beyond our earthly experience. The temperature hovers just a few degrees above absolute zero, the point where all motion ceases. In this state, the ice within it, water ice, frozen methane, ammonia, carbon dioxide, was as hard and as permanent as rock. Locked within that ice were grains of dust, silicates, and perhaps even complex organic molecules, the very building blocks of life, preserved in a perfect cosmic time capsule. For millions of years, it fell. Not in a dramatic plummet, but in a slow, graceful, patient spiral. It moved through the outer darkness where the planets are gas giants, their distant light too faint to warm its surface. It passed the orbit of Neptune, a blue-green marble so far away it would be invisible to the naked eye. It drifted past Uranus, the ice giant spinning on its side. It coasted through the realm of Saturn, its majestic rings a distant shimmering line of light. And still it fell, drawn inward by the one constant in our solar system, the gravity of the sun. As it journeyed, the universe around it was largely unchanged. The constellations it moved against are the same ones we see, their patterns shifting only over timescales far longer than this journey. The Wanderer was a silent witness to the slow, stately dance of the cosmos, It carried the memory of the outer dark within its very core. It's a story that feels both immense and impersonal. But as we continue our journey together tonight, exploring the quiet corners of cosmic mystery, perhaps you'll find a sense of connection to these grand, slow stories. If you enjoy letting your mind drift among the stars, consider following this channel for more voyages into the gentle unknown. It's a way for us to ensure we can continue to meet here in this quiet space and wonder about the universe together. But for now, let's just stay with our traveller. Let's return to the Wanderer. As it crossed the orbit of Jupiter, the largest of the planets, something began to change. The Sun, which for so long had been just a particularly bright star, was now becoming a distinct disk. Its light, even out here, carried a faint warmth. For the first time in millions of years, the surface of the Wanderer began to feel a new energy. The ancient, deep, frozen ices were stirring. This is the magic of a comet. It is a transformation. What was once a dark, inert piece of rock and ice begins to wake up. The process is called sublimation. The sun's energy doesn't melt the ice into water, it turns it directly into a gas. A whisper of vapour begins to lift from the surface, carrying with it the fine dust that was trapped within the ice for billions of years. This is what the astronomers on Earth first saw, not the solid body of the comet itself. That nucleus is perhaps only a few kilometres across, far too small and dark to see from so far away. What they saw was the cloud of gas and dust that was forming around it. This cloud is called the coma. It is a temporary atmosphere, a ghostly shroud that grows as the comet gets closer and closer to the sun's fire. Imagine you're floating in space, a safe distance away, watching this process unfold. You would see the dark, irregular shape of the nucleus, a landscape of frozen peaks and valleys that have never known a sunrise. And from its surface you would see silent, gentle plumes of gas erupting, catching the sunlight and glowing with a soft, ethereal light. It is a quiet, continuous birth, a world awakening. This coma, this glowing cloud, can grow to be enormous, sometimes larger than a planet. It is incredibly thin, more tenuous than any vacuum we can create on Earth, but it is vast. And as the Wanderer continued its journey inward, this coma grew brighter and larger. Then, another transformation begins. The sun is not just a source of light and heat. It is also the source of the solar wind, a constant stream of charged particles flowing outward into space at hundreds of kilometers per second. This invisible wind pushes against the delicate coma of the comet. It sweeps the gas and dust backward, away from the sun, forming a tail, or more accurately two tails. There is the dust tail, which is made of the larger particles, the fine grains of rock and soot that were mixed in with the ice. These particles are heavier, and they are pushed back by the pressure of sunlight itself. They tend to curve gracefully, following the comet's orbital path, glowing a soft yellowish white as they reflect the light of the sun. This tail marks the road the Wanderer has travelled, and then there is the ion tail, or the gas tail. This is made of the gas that has been ionized by the sun's ultraviolet radiation, its electrons stripped away. This ionized gas is then caught by the magnetic field of the solar wind and pushed directly away from the sun, regardless of the comet's direction of travel. It glows with a faint, beautiful blue light, the light of excited carbon monoxide ions. This tail is a cosmic weather vane, pointing directly away from the heart of our solar system. So when astronomers first saw 3I Atlas, this is what they were seeing: a growing coma and the first hints of these two developing tails. They were witnessing the final act of a multi-million-year journey. A celestial object that had been dormant for longer than humanity has existed was finally putting on a display for us. At first, there was great excitement. The calculations of its orbit and its rate of brightening suggested that 3I Atlas could become a truly spectacular sight in our night sky. It might become bright enough to be seen with the naked eye, a rare and beautiful visitor gracing our evenings and early mornings. People prepared their telescopes and a sense of anticipation grew. Here was a direct, visible connection to that cold, distant, mysterious part of our solar system. A piece of the outer dark, visiting our neighborhood. We can pause here for a moment and just contemplate this image. A single, small body, no bigger than a mountain, traveling for an unimaginable length of time, carrying within it the pristine, unaltered material from which our Earth and all the other planets were formed 4.5 billion years ago. It is a time capsule, a history book, and a celestial spectacle all in one. It travels not with a roar or a great engine, but in perfect silence, governed only by the gentle, persistent pull of gravity. Its path is a perfect ellipse, a curve calculated by the laws of physics, as predictable and as elegant as a mathematical formula. And yet, within that predictability, there is so much mystery. What would the surface of such an object look like up close? We have seen other comets through the eyes of our robotic probes. We have seen dark, almost black surfaces covered in a fine, powdery dust. We have seen jagged cliffs and smooth plains of ice. We have seen jets of gas erupting suddenly from fissures as the sun warms a pocket of volatile ice hidden just beneath the surface. Each comet is its own unique world, with its own history and its own character. What stories could the wanderer tell if we could only listen? The dust grains within it might have been formed in the atmosphere of a dying star, long before our sun was even born. The water ice it carries is the same water, chemically, that fills our oceans and falls as rain. The organic molecules it holds are a reminder that the ingredients for life are not unique to Earth, but are scattered throughout the cosmos, waiting. As 3i Atlas continued its approach through the early months of 2020, it continued to brighten, just as predicted. It moved from the constellation of Ursa Major, the Great Bear, down towards Camelopardalis, the Giraffe. Night after night, amateur and professional astronomers tracked its progress, measuring its brightness, analysing the light from its coma to understand its chemical composition. It was a collective act of watching, of welcoming this visitor. But comets are notoriously unpredictable. They are not solid, uniform spheres of rock like an asteroid. They are fragile, loosely bound conglomerates of ice and dust. They are in a sense cosmic snowballs, and sometimes, under the increasing stress of the sun's heat and gravity, they can fall apart. In late March and early April of 2020, something began to change. The wanderer stopped brightening. In fact, it began to fade. Observations from telescopes, including the Hubble Space Telescope, revealed why. The nucleus, the solid heart of the comet, was breaking apart. It wasn't a violent explosion, but a quiet, graceful disintegration. The single point of light had fractured into several smaller pieces, each now moving away from the others, continuing on the same path, but no longer a single, coherent object. The great show was over before it had truly begun. The wanderer, after its journey of millions of years, could not survive its first close encounter with our sun. It was dissolving, its substance given back to the solar system from which it came. The fragments continued to travel, each with its own faint coma, a small fleet of ghosts following the path of their parent. And then, after passing its closest point to the sun, it began its long journey back out, back towards the cold and the dark from which it came. It will not return for thousands of years. There is a kind of poetry in this, a gentle melancholy, a journey of millions of years, ending in a quiet dissolution. It did not become the spectacular sight we had hoped for. It did not light up our night sky. Instead, it gave us something else. It gave us a reminder of the fragility of these celestial visitors. It showed us a process of creation and decay that happens on a cosmic scale. And it left us with a deeper sense of the immense and powerful forces that govern our solar system. The same sun that gives us life and warmth can, with its gentle pressure, unmake a world that has been stable for eons. But our story tonight does not end here. In fact, this is just the beginning. Because the mystery of 3i Atlas is not just about its journey or its quiet demise, it's a question that begins to form when we connect this lonely traveller with another, even more profound mystery. A mystery that came not as a faint smudge of light, but as a sound. A whisper from the stars heard once, and never again. It's a question that might seem unlikely, even impossible at first. How could a small, disintegrating comet, a simple ball of ice and dust, have any connection to a powerful, intelligent-seeming radio signal from deep space? It's a question that challenges our assumptions about how the universe works and what might be possible in the vast, silent spaces between the stars. But as you continue to drift, as you let the weight of the day fall away, let this question settle gently in your mind. What if this wanderer, this visitor from the outer dark, was more than just a comet? What if its journey through our solar system was part of a much larger story? What if its path, its timing, and its very substance were somehow entangled with a signal that has puzzled humanity for nearly half a century? This is the path we will walk tonight. We will hold these two mysteries in our hands, the comet and the signal. We will look at them from all angles with a sense of peaceful wonder. We will not search for hard answers, but for beautiful possibilities. We will explore the science, the speculation, and the philosophical implications of a potential connection. So let the image of the wanderer stay with you. A small, fragile object, making its way through the immense darkness of space. Feel the scale of its journey, the millions of years of silence. Picture the gentle awakening as it neared the sun, the soft glow of its coma, the graceful sweep of its tails, and see its quiet dissolution, a return of its substance to the cosmos. It is a complete story in itself, a story of cosmic time, of gravitational dance, of creation and unmaking. But perhaps it is only the first chapter of a much stranger and more wonderful story, a story that begins not with a telescope, but with an ear pointed to the heavens, listening for a voice in the static. And it is there, in a quiet field in Ohio, in the summer of 1977, that the second part of our mystery begins. The year is 1977. The world is a different place. The Cold War is at its height. The space race has slowed after the moon landings, and personal computers are still the stuff of science fiction for most people. In the heartland of America, in Delaware County, Ohio, there stands a remarkable instrument. It is not beautiful in the conventional sense. It is a collection of metal beams and aluminum panels stretching across a field like a giant grounded airplane wing. This is the Big Ear Radio Telescope, operated by Ohio State University. Unlike optical telescopes that gather light, Big Ear gathers radio waves, the invisible electromagnetic radiation that fills the universe. It is, in essence, a giant ear, listening to the cosmic static, the background hum of the universe. The Big Ear was not built to search for extraterrestrial intelligence, though that is what it had been doing for several years by 1977. It was originally constructed to survey the radio sky, to map the natural sources of radio emission, distant galaxies, pulsars, quasars. But in 1973, after completing its survey, it was repurposed for something more speculative, more hopeful. It became part of the search for extraterrestrial intelligence, SETI. Day after day, night after night, it listened. It scanned the sky in narrow strips, recording the intensity of radio waves at specific frequencies. Most of what it heard was predictable. The radio emissions from distant astronomical objects, the interference from Earth-based technology, the occasional burst from a satellite passing overhead. It was like listening to static on an old radio, searching for a clear station among the noise. The telescope operated largely automatically. It would scan the sky as the Earth rotated, recording data on a continuous printout. This data would then be reviewed by volunteers, people who would spend hours looking at rows and rows of numbers, searching for anything unusual. It was tedious work, requiring patience and attention to detail. Most days there was nothing, just the regular, predictable patterns of cosmic noise. But on August 15th, 1977, something extraordinary happened. The telescope was pointed towards the constellation Sagittarius, near the star group Chi Sagittarii. It was a region of sky like any other, with no particular significance. The telescope was simply following its programmed sweep of the heavens. But at 10:16 p.m. Eastern Daylight Time, for exactly 72 seconds, Big Ear heard something it had never heard before. The signal was narrow band, meaning it was concentrated at a very specific frequency, 1420 56 MHz. This frequency is special. It is the frequency at which hydrogen, the most abundant element in the universe, naturally emits radio waves. It's called the hydrogen line, or the 21 centimeter line, because the wavelength of this radiation is 21 centimeters. Scientists had long speculated that if an intelligent civilization wanted to send a signal that other intelligent beings might notice, they might choose this frequency. It's a universal constant, a frequency that any civilization with radio technology would know about. It's like a cosmic meeting place, a channel that everyone would think to tune into. The signal was strong, about 30 times stronger than the background noise. It rose and fell in intensity exactly as you would expect if a distant fixed source was passing through the telescope's beam as the Earth rotated. It wasn't a sudden burst or a continuous tone. It had a specific pattern, a signature that suggested it came from a single point in space, far beyond our solar system. The computer recorded the signal's intensity as a series of alphanumeric characters. Most of the time, these characters were ones and twos representing the low-level background noise. But for those 72 seconds, the characters climbed. 6, then E, then Q, then U, then J, then 5. In this system, the letters represented numbers greater than 9, with U being the highest value the system could record. This was a powerful signal. Days later, when Jerry Eman, a volunteer astronomer, was reviewing the printouts, he saw this sequence. He immediately recognized its significance. This was not normal. This was not background noise or interference. This was something extraordinary. In his excitement, he grabbed a red pen and circled the sequence, writing a single word in the margin. Wow! And so, the signal got its name. The Wow signal. It has become one of the most famous and mysterious events in the history of astronomy. Because here's the truly puzzling part. The signal was never detected again. Big Ear continued to listen to that same patch of sky for months afterward. Other radio telescopes around the world pointed their dishes in that direction. More sensitive instruments, more advanced techniques were employed, but the signal was gone. It had appeared once for 72 seconds and then vanished completely. If it was a message, it was a message spoken once and never repeated. If it was a beacon, it was a lighthouse that flashed only once. This absence of repetition is what makes the Wow signal so mysterious. Natural astronomical sources of radio waves, like pulsars or quasars, are consistent. They emit signals continuously or in regular patterns. Human-made signals like satellites or aircraft can be tracked and identified, but the Wow signal fits neither category. It appeared, it was recorded, and it disappeared, leaving only questions. Scientists have proposed many explanations over the years. Perhaps it was a piece of space debris reflecting a terrestrial signal back to Earth. But the frequency was protected. No Earth-based transmitters are allowed to broadcast at 1420 MHz precisely to avoid interference with astronomical observations. Perhaps it was a secret military satellite. But no known satellite was in the right position at the right time, and the signal's characteristics don't match typical satellite transmissions. Perhaps it was a natural phenomenon we don't yet understand. In 2016, a scientist proposed that the signal might have been caused by a comet. specifically the comets 266P Christensen or 335P Gibbs, which were in the vicinity at the time. The idea was that the hydrogen cloud surrounding a comet might emit at the hydrogen line frequency. But this explanation has been largely dismissed by the scientific community. The signal was too strong, too narrow band, and comets simply don't emit radio waves in this way. So we are left with the mystery. A powerful narrowband signal at the hydrogen line frequency, coming from a specific point in space, lasting exactly as long as it would take for a distant source to pass through the telescope's beam and never detected again. It remains unexplained. It sits there in the data, a 72-second anomaly in decades of listening, a question mark in our understanding of the universe. And this brings us to a thought, a gentle speculation that we can hold lightly as we drift towards sleep. What if the WOW signal and our wanderer 3I Atlas are connected? Not directly, not in any obvious way, but through the strange, subtle interconnections that weave through the cosmos. Consider the timing. The WOW signal was detected in 1977. At that time, 3I Atlas was still far out in the depths of the solar system, perhaps just beginning its long fall towards the sun. It wouldn't be discovered for another 42 years. But its orbit was already determined, its path already set by the laws of gravity. It was already on its way, a silent messenger approaching through the dark. What if the signal was not meant for us, but was related to the comet in some way we don't yet understand? What if it was a marker, a cosmic notification that something was coming? Or what if the comet, in its journey through the outer solar system, passed through some kind of field or region that triggered the signal? These are not scientific hypotheses. They are dreams, imaginings, gentle wonderings that we can entertain without needing them to be true. Perhaps the universe is full of such connections, subtle links between events separated by vast distances and long spans of time. Perhaps there are patterns and purposes that we, with our limited perspective, cannot yet see. Perhaps every comet that falls towards the sun carries with it some kind of information, some kind of message encoded in its ice and dust. And perhaps, just perhaps, the WOW signal was the universe's way of saying, pay attention, something is coming. We don't know. We can't know. And that's part of the beauty of it. The universe keeps its secrets, revealing them slowly, if at all. It invites us to wonder, to speculate, to dream. It gives us mysteries like the WOW, signal and visitors like 3I Atlas, and it asks us to make of them what we will. As you lie there, feeling the weight of your body against the bed, feeling the slow rhythm of your breath, you can hold these two mysteries in your mind. A signal from the stars heard once in 1977, a comet from the outer darkness, seen briefly in 2020, two events separated by decades, possibly unconnected, possibly part of some larger pattern we cannot perceive. Let them float there in your consciousness, not as problems to be solved, but as wonders to be contemplated. The universe is vast and we are small, but in our smallness we have the capacity for wonder. We can look up at the night sky and ask questions. We can build instruments to listen to the cosmos. We can track the paths of comets and puzzle over mysterious signals. We can dream of connections and possibilities, and perhaps that is enough. Perhaps the questions are more important than the answers. Perhaps the mystery is more beautiful than any explanation could be. The WOW signal remains unexplained. 3I Atlas has dissolved and continued on its journey back to the outer darkness. But they have left their marks on us, these two cosmic events. They have given us moments of wonder, opportunities to think beyond our everyday concerns and contemplate the vastness and mystery of the universe we inhabit. So let yourself drift now, carried by these thoughts like a comet carried by gravity. Let the mysteries of the cosmos be your companions as you journey towards sleep. The signal and the comet, the question and the wonder. all floating together in the peaceful darkness of space and mind. Now, to truly understand our wanderer and the possibility of its connection to that mysterious signal, we must journey to its birthplace. We must travel beyond Neptune, beyond the Kuiper belt, beyond the farthest reaches of what we typically think of as our solar system. We must venture into a realm so vast, so cold, and so silent that it challenges our earthbound imagination. We must enter the Oort cloud. Close your eyes and imagine you're drifting outward from the sun. You pass the Earth, blue and white and alive, receding behind you. You pass Mars, red and dusty and quiet. You sail through the asteroid belt, a scattered field of tumbling rocks. You pass the giant Jupiter with its swirling storms and dozens of moons. You continue past Saturn, its rings catching the distant sunlight like a cosmic crown. Uranus and Neptune fall behind, the ice giants guarding the outer reaches of the planetary realm. But you don't stop. You continue outward, into the darkness. The sun, which even at Neptune's distance is still the brightest object in the sky, continues to shrink. It becomes just another star, perhaps a bit brighter than the others, but no longer the dominant presence it is for us on Earth. You are entering the realm of the Kuiper belt, where Pluto and its companions orbit in the eternal twilight. But even this is not your destination. You must go further still, much, much further. Imagine travelling for months, years, decades at the speed of light itself. The sun continues to fade, becoming fainter and fainter until it is truly just one star among countless others. The familiar constellations begin to distort as your perspective shifts. The cosmos around you is no longer the cosmos as seen from Earth. You're in the true wilderness of space, the vast emptiness between the stars. And then, after a journey that would take our fastest spacecraft tens of thousands of years, you begin to enter a new realm. You can't see it, not directly. It is too dark, too sparse, too vast. But it is there, all around you. You have entered the Oort cloud. The Oort cloud is not a cloud in any sense that we understand on Earth. It is not dense or opaque or visible. It is a sphere, or perhaps a shell, of icy bodies surrounding our solar system at a distance that is almost incomprehensible. The inner edge of the Oort cloud is thought to begin around 2,000 astronomical units from the Sun. An astronomical unit, or AU, is the distance from the Earth to the Sun, about 150 million kilometers. So the inner edge of the Oort cloud is 2,000 times further from the Sun than we are. Neptune, the outermost major planet, orbits at just 30 AU. The Oort cloud begins where the influence of the Sun's gravity becomes weak, where the tug of other stars begins to matter. But the Oort cloud doesn't stop there. It extends outward, possibly as far as 100,000 AU from the Sun. That's more than a light year, a quarter of the distance to the nearest star, Proxima Centauri. In this vast spherical shell, there are thought to be trillions of icy bodies. Trillions. Each one a potential comet, waiting for the gentle gravitational nudge that will send it falling towards the Sun. These objects are the leftover building blocks of our solar system. When the Sun and planets formed 4.6 billion years ago from a collapsing cloud of gas and dust, not all of the material ended up in the Sun or the planets. Some of it was flung outward by the gravitational interactions with the forming giant planets, especially Jupiter. These icy planetesimals were scattered to the far reaches of the Sun's gravitational influence, where they have remained ever since, frozen in time and space. Think about the conditions out there. The temperature is just a few degrees above absolute zero, about 270 degrees Celsius. At this temperature, everything is frozen. Water ice is as hard as rock. Methane, which on Earth is a gas, is a solid. Even substances like nitrogen and carbon monoxide, which we never experience as solids on Earth, are frozen into exotic ices. There is no weather, no wind, no change. Each of these trillions of objects sits in its orbit, following a path that might take millions of years to complete. They are so far from each other that collisions are essentially impossible. Each one is alone, isolated in its own small region of space. The darkness is absolute. The Sun, even though it is still the gravitational master of this realm, provides essentially no light. Starlight is the only illumination, and it is faint, just enough to see by if you had eyes adapted to such darkness. In this silent, frozen realm, time moves differently. Not in any relativistic sense, but in terms of change and activity. On Earth, we're used to constant change. Weather systems develop and dissipate in days. Seasons change over months. Rivers carve new channels over years. Mountains rise and fall over millions of years. But in the Oort cloud, nothing changes. A piece of ice that formed when our solar system was young looks exactly the same today as it did 4 billion years ago. There has been no weathering, no erosion, no chemical reactions. It is a cosmic time capsule, a library of our solar system's earliest history written in ice and dust. The objects in the Oort cloud are not just simple chunks of ice. They are complex, differentiated bodies. They contain water ice, of course, but also frozen ammonia, methane, carbon dioxide and carbon monoxide. Mixed in with these ices are grains of rock and dust, silicates and metals that formed in the hearts of dying stars before our sun was born. And perhaps most intriguingly, they contain organic molecules. Not life, but the complex carbon-based molecules that are the building blocks of life. Amino acids, the components of proteins. Nucleobases, the letters of the genetic code. These molecules formed in the cold depths of space, created by the slow interaction of simpler molecules and cosmic radiation over billions of years. Each object in the Oort cloud is like a book, and the library contains trillions of volumes. Some are small, perhaps just a few meters across. Others are larger, kilometers or even tens of kilometers in diameter. Each one has its own composition, its own history, its own story to tell. And they have been sitting there, unread, for the entire history of our solar system. Occasionally, very occasionally, one of these books is checked out of the library. A passing star, perhaps once every few million years, comes close enough to our solar system to disturb the Oort cloud. Its gravity doesn't need to be strong, just enough to change the orbit of some of these icy bodies slightly. That small change can be enough to send an object falling towards the sun. This is how long-period comets are born. They begin their journey from the edge of the sun's influence, falling for millions of years before they enter the inner solar system and become visible to us on Earth. Our wanderer, 3i Atlas, was one of these. Somewhere, perhaps 1 million years ago, perhaps 10 million, something disturbed its orbit. Maybe it was the star Gliese 710, which is currently approaching our solar system and will pass within about 0.2 light-years in about 1.3 million years. Or maybe it was another star, one that passed by long ago and is now far away, continuing its own journey through the galaxy. The disturbance was gentle, subtle. The wanderer's orbit changed just slightly. Instead of continuing its eternal circuit in the outer darkness, it began to fall, slowly at first, almost imperceptibly. But gravity is patient and persistent. Year after year, century after century, millennium after millennium, the wanderer fell inward, gaining speed as it approached the sun. Think about what the wanderer experienced on this journey. For most of it, there was no change at all. The sun remained just a bright star among many. The wanderer's surface remained frozen, its ices locked in their billion-year stasis. It was a journey measured not in distances that we can comprehend, but in time. Generations of humans lived and died. Civilizations rose and fell. The entire history of recorded human civilization, from the first cities in Mesopotamia to the present day, is just a tiny fraction of the wanderer's journey time. And for all of that time, it was silent, dark, and alone. But the wanderer carried something with it. It carried the pristine material of the early solar system. It carried water that has never been liquid, at least not since the solar system formed. It carried organic molecules that have never been part of a living system. It carried the dust of stars that died before our sun was born. It was a messenger from the deep past, carrying information about conditions and processes that we can never directly observe. When we study comets, we are reading these messages. We are learning about the composition of the original solar nebula, the cloud of gas and dust from which the sun and planets formed. We are discovering what kinds of organic molecules can form in the cold depths of space. We are piecing together the history of our cosmic neighborhood. But perhaps comets carry other kinds of messages too. Perhaps the arrangement of their molecules, the specific mixture of ices and dust, encodes information in ways we don't yet understand. Perhaps the Oort cloud is not just a reservoir of comets, but a kind of cosmic memory bank, storing information about the galaxy's past. Perhaps each comet that falls towards the sun is like a neuron firing in a vast, slow, cosmic brain. These are fanciful thoughts, not scientific hypotheses. But as we drift here in the darkness, contemplating the vastness of the Oort cloud, such thoughts seem less impossible and more like gentle possibilities. Consider this. The Oort cloud is not unique to our solar system. Every star probably has its own Oort cloud, its own shell of icy bodies extending far into space. These Oort clouds must sometimes overlap or at least come close to each other as stars pass by. Could objects be exchanged between them? Could a comet that formed around another star find its way into our solar system? Some scientists think this is not only possible but likely. They have even identified a few objects that might be interstellar visitors, captured by our sun's gravity long ago. If this is true, then comets are not just messengers from our own solar system's past. They could be messengers from other stars carrying information about conditions in other parts of the galaxy. They could be natural probes, unconscious ambassadors travelling between stellar systems over millions of years. And this brings us back to our central mystery. What if the wow signal was related to such an exchange? What if it was a marker or a notification that an object from another star was entering our solar system? What if 3I Atlas was not originally from our Oort cloud, but from the Oort cloud of another star? What if its approach was somehow announced by that powerful radio signal in 1977? Again, these are not scientific claims. They are wonderings, gentle speculations that we can entertain as we drift towards sleep. But they remind us that the universe is far stranger and more interconnected than we often imagine. The Oort cloud, in its vast silent darkness, might be a place where different stellar systems touch, where information and material are slowly exchanged over cosmic time. As you float here in your imagination, surrounded by the trillion icy bodies of the Oort cloud, feel the profound stillness of this place. There is no sound, no movement that you can perceive. Each object follows its orbit in perfect silence, has been following it for billions of years, will continue to follow it for billions more. It is a place of patience, of waiting, of cosmic meditation. The Oort cloud is like the universe's memory, holding the original materials from which our world was made. It is a library that is mostly unread, its books unopened. Occasionally, one volume falls from the shelves and makes its way to us, like 3I Atlas did. We read what we can in the brief time before it returns to the darkness. But the library remains, vast and patient and full of secrets. Feel yourself drifting among these icy bodies. Each one is a world unto itself, with its own geography of frozen peaks and valleys, its own mixture of ices and dust. Some might have cores of rock beneath their icy shells. Others might be loose aggregations held together by the weakest of forces. Some might be almost pure water ice. Others might be rich in exotic ices and organic molecules. Each one is a unique creation, a cosmic snowflake that has never melted. And somewhere among these trillions of objects, there might be something extraordinary. Perhaps an object that is not natural at all, but artificial. Perhaps a probe from another civilization, disguised as a comet, waiting in the cold darkness. Perhaps an object that contains not just organic molecules, but actual preserved microorganisms, life in suspended animation, waiting to be awakened by the warmth of a star. These are the dreams of scientists and science fiction writers, but who can say they are impossible? The Oort cloud is so vast, so unexplored, that almost anything could be hidden there. We have never sent a spacecraft to the Oort cloud. It would take tens of thousands of years with our current technology. We can only observe it indirectly through the comets that occasionally visit us. It remains one of the last true frontiers in our solar system, a place of mystery and possibility. And it is from this place that our wanderer came. It spent most of its existence in that cold, dark realm, orbiting slowly, patiently, silently. Then something changed, and it began its long fall towards the sun. It passed through the Kuiper belt, past Neptune and Uranus, past Saturn and Jupiter. It entered the inner solar system, where the sun's warmth finally woke it from its billion-year sleep. It developed its coma and its tails, putting on a brief show for anyone watching, and then it broke apart, unable to withstand the stresses of its close encounter with our star. But perhaps its mission was already complete. Perhaps it had already delivered whatever message it was carrying. Perhaps the organic molecules it released as it dissolved will eventually find their way to Earth, adding their information to our planet's chemical library. Perhaps the dust grains it shed will be incorporated into new comets, new planets, new possibilities. Or perhaps its purpose was simply to make us wonder, to remind us of the vastness and mystery of the cosmos, to inspire us to keep looking up and asking questions. The Oort cloud remains out there, a spherical shell of ice and possibility surrounding our solar system. It connects us to the deep past and perhaps to other stars. It is a reminder that our solar system is not isolated but is part of a larger galactic community, and from time to time it sends us visitors like Three-Eye Atlas, brief glimpses of its vast frozen library. As you drift towards sleep, let the image of the Oort cloud stay with you, a sphere of darkness and ice, patient and eternal, a place where time moves slowly and nothing changes, a reservoir of cosmic history and possibility. And somewhere in that vastness, other objects are beginning their own journeys, disturbed by passing stars or galactic tides. Future comets that will one day grace Earth's skies, carrying their own messages from the frozen edge of our solar system. The cosmos is full of such journeys, such messages, such mysteries. And we, in our brief moment of consciousness, have the privilege of witnessing some of them, of wondering about them, of being part of the grand, slow, beautiful dance of the universe. The Oort cloud whispers its secrets in the language of comets, and we are just learning how to listen. What stories will the next visitor tell? What mysteries will it bring? We can only wait and watch and wonder. The journey from the Oort cloud has brought us to a very different place and time. We leave behind the vast, frozen darkness and travel not just through space but through time as well. We move from the cosmic scale to the human scale, from billions of years to a single summer evening. We arrive in Ohio in the year 1977, where we will witness one of the most intriguing moments in the history of our species' attempt to listen to the cosmos. Picture, if you will, a warm August evening in the American Midwest. The sun has set, painting the western sky in fades of orange and purple. The first stars are beginning to appear. Crickets are singing their ancient songs in the fields. It is a peaceful, ordinary evening, the kind that has happened countless times throughout human history. But on this particular evening, something extraordinary is about to occur. In Delaware County, Ohio, about 20 miles north of Columbus, there stands a peculiar structure. To someone driving by on the nearby road, it might look like some kind of agricultural equipment, or perhaps an abandoned construction project. It is neither beautiful nor imposing. It is functional, utilitarian, a tool built for a specific purpose. This is the Big Ear Radio Telescope, and on this August evening it is doing what it has done every night for years, listening to the cosmos. The Big Ear is not like the telescopes most people imagine. It has no giant dish that can be pointed at different parts of the sky. Instead, it consists of two reflectors, each about 100 meters long and 30 meters high, standing parallel to each other like the walls of a roofless building. Between them, the ground is covered with a flat aluminum surface. Radio waves from space bounce off one reflector, then off the ground, then off the other reflector, finally focusing on a small receiver. The entire structure is fixed in place. It cannot be steered or pointed. Instead, it relies on the rotation of the Earth to sweep its beam across the sky. This design might seem primitive compared to modern radio telescopes, but it was remarkably effective for its purpose. As the Earth rotates, the telescope's beam traces a path across the sky, like a lighthouse beam sweeping across the ocean. Any radio source in that path will be detected as it passes through the beam. The stronger the source, the stronger the signal recorded by the telescope's receivers. The Big Ear had been built in the 1960s for a different purpose. Originally, it was designed to survey the radio sky, to create maps of natural radio sources. For years, it had catalogued thousands of radio sources, distant galaxies, quasars, pulsars, and other exotic objects that emit radio waves. But by 1973, that survey was complete, and the telescope needed new purpose. That's when it was dedicated to SETI, the search for extraterrestrial intelligence. The idea behind SETI is both simple and profound. If there are other technological civilizations in the galaxy, they might use radio waves for communication just as we do. Some of those radio waves might leak into space, just as our television and radio broadcasts leak into space. Or perhaps these civilizations might deliberately broadcast signals hoping to make contact with others like them. If we listen carefully, systematically, patiently, we might detect these signals. We might discover that we are not alone. It is an idea that captures the imagination. But the practical reality of SETI is far less romantic. It involves endless hours of recording data, most of which is noise. It involves checking and rechecking equipment, eliminating sources of interference, analyzing patterns that almost always turn out to be natural or human-made. It is like searching for a needle in a haystack, except you're not sure there is a needle. You don't know what the needle looks like, and the haystack is the size of the galaxy. The Big Ear was not staffed at night. The telescope operated automatically, controlled by a computer that was advanced for its time but primitive by today's standards. The computer controlled the receivers, switching between different frequency channels, recording the intensity of the signal at each frequency. The data was printed out on continuous paper, the kind with holes along the edges that fed through the printer. Each line of data represented a few seconds of observation. Each column represented a different frequency channel. The numbers and letters printed on the paper represented the intensity of the signal, with 1 being the weakest and U being the strongest the system could record. Most of the time, the printout showed 1s and 2s, with occasional 3s or 4s when the telescope passed over a known radio source. This was the normal background of the universe, the cosmic static that fills all of space. On the night of August 15th, 1977, the telescope was operating normally. It was pointed, as it always was, straight up, waiting for the rotation of the Earth to bring different parts of the sky into view. The region of sky passing through the telescope's beam that night was in the constellation Sagittarius, not far from the star Chi Sagittarii. This is a region of sky that points towards the center of our galaxy, where stars are more densely packed and where, statistically, there might be a higher chance of finding other civilizations. But there was nothing special about this particular night, or this particular observation. It was routine, another night in the long, patient search. At 10:16 p.m. Eastern Daylight Time, the telescope's beam swept across a particular point in space. For 72 seconds, the receivers detected a signal unlike anything they had recorded before. It was narrow-band, concentrated at a frequency of 1420.45 MHz. It was strong, about 30 times stronger than the background noise, and it had a very specific pattern. The signal rose in intensity as the source entered the telescope's beam, reached a peak when the source was centered in the beam, and then fell as the source exited the beam. This is exactly what you would expect from a distant point-like source, something far beyond our solar system. The computer dutifully recorded this signal, printing it out as a sequence of characters, 6EQ-J5. In the system used by Big Ear, this represented a signal that started at intensity 6, rose to E, equivalent to 14, then Q, 26, then U, 30, the maximum the system could record, then fell to J, 19, and finally 5. This pattern, rising and falling over 72 seconds, was consistent with the telescope's beam width and the rotation of the Earth. Whatever the source was, it was not moving relative to the stars. It was either very far away, or it was something in Earth orbit that happened to be stationary relative to the stars for those 72 seconds. But there were no known satellites in that position, and no Earth-based transmitters are allowed to broadcast at that exact frequency. The frequency itself is significant. 14 to 20 MHz is the frequency of the hydrogen line, the natural emission frequency of neutral hydrogen atoms. Hydrogen is the most abundant element in the universe, and this frequency is like a universal constant, something that any technological civilization would know about. In 1959, two physicists, Giuseppe Cocconi and Philip Morrison, had suggested that this frequency would be an obvious choice for interstellar communication. It's quiet, with little natural or artificial interference. It's a frequency that stands out, that says this is not random, this is chosen. If you wanted to send a signal that other intelligent beings might notice, this would be the frequency to use. The signal was recorded automatically, and then the telescope moved on, continuing its endless sweep of the sky. The printout rolled on, returning to its normal pattern of 1s and 2s. The extraordinary had become ordinary again in just 72 seconds. Nobody knew in that moment that something remarkable had been recorded. The telescope continued its observations through the night, and the printout continued to accumulate, waiting for human eyes to review it. It wasn't until several days later that Jerry Eman, a volunteer with the SETI project, sat down to review the printouts from that week. He was looking for anomalies, for anything that stood out from the normal background noise. Most of the time, there was nothing. Occasionally, there would be a spike that turned out to be interference from a passing airplane or a distant thunderstorm. But when he saw the sequence 6EQUJ5, he immediately recognized that this was different. The pattern was too perfect. The rise and fall matched exactly what would be expected from a celestial source. The frequency was precisely the hydrogen line. The signal strength was far above anything that could be explained by natural variation or equipment malfunction. Eman grabbed a red pen and circled the sequence. In the margin, he wrote a single word that would give the signal its name. Wow! It was an expression of genuine astonishment, the kind of involuntary exclamation that escapes when you encounter something truly unexpected. In that moment, Eman thought he might be looking at the first evidence of extraterrestrial intelligence. The excitement must have been incredible. Imagine being the first person to recognize what this signal might represent. For years, SETI researchers have been listening, hoping, waiting for exactly this kind of signal. And here it was, printed out in simple alphanumeric characters on a piece of computer paper. It wasn't a message that could be decoded, not yet anyway. It was just a carrier wave, a pure tone at a significant frequency. But it was artificial, or at least it appeared to be. It was exactly what they had been looking for. But science requires verification. A single detection, no matter how promising, is not enough. The signal needed to be detected again, confirmed by other observations. So Big Ear was immediately tasked with observing the same region of sky. The telescope returned to the position where the signal had been detected, listening on the same frequency, waiting for the signal to repeat. But it didn't repeat. Night after night the telescope listened, but there was only silence. The source, whatever it was, had gone quiet. Other radio telescopes around the world were alerted. They too pointed their dishes at the region near Sagittari, listening for any trace of the signal. More sensitive telescopes, more sophisticated equipment, more careful observations. But still, there was nothing. The signal had appeared once for 72 seconds and then vanished completely. This is what makes the "wow" signal so frustrating and so fascinating. If it was a beacon from another civilization, why did it only broadcast once? If it was a message, why wasn't it repeated? Radio communications from Earth, when we send messages into space, are typically repeated many times to ensure they have a chance of being detected. A one-time signal seems almost designed to be missed. Over the years, many explanations have been proposed. Perhaps it was a reflection of an Earth-based signal off a piece of space debris. But the frequency is protected. No one is allowed to transmit at exactly 1420 MHz. Perhaps it was a secret military satellite. But no known satellite was in the right position, and the signal characteristics don't match typical satellite transmissions. Perhaps it was a natural phenomenon, something we don't yet understand about the universe. But what natural phenomenon would produce such a narrow band signal at exactly the hydrogen line frequency? In 2016, astronomer Antonio Paris proposed that the signal might have been caused by one of two comets, 266P Christensen or 335P Gibbs, which were in the general area at the time. His hypothesis was that the cloud of hydrogen gas surrounding these comets might emit at the hydrogen line frequency. He even claimed to have detected similar signals from these comets using a small radio telescope. But this explanation has been widely criticized and largely rejected by the scientific community. The comets were not in exactly the right position. More importantly, comets simply don't emit radio signals in this way. The hydrogen around a comet is not in the right state to produce such a strong, narrow band emission. And even if it could, why haven't we detected similar signals from the hundreds of other comets we've observed? The comet hypothesis, while creative, doesn't hold up to scrutiny. So we're left with the mystery. A powerful, narrow band signal at exactly the hydrogen line frequency, coming from a specific point in space, following exactly the pattern expected from a distant source, and never detected again despite decades of searching. It remains one of the most tantalizing mysteries in astronomy. It's not proof of extraterrestrial intelligence, but it's not easily explained by any known natural or artificial phenomenon either. It sits in that uncomfortable space between knowledge and speculation, between science and wonder. Think about what it would mean if the signal really was from another civilization. It would mean that on August 15th, 1977, for 72 seconds, we were not alone. Someone, or something, was broadcasting a signal powerful enough to be detected across interstellar distances. They chose the hydrogen line frequency, suggesting they understood the same physics we do, that they were thinking about communication in the same way we are. But why only once? Perhaps it wasn't meant for us at all. Perhaps we accidentally intercepted a communication between two distant points, like hearing a fragment of a conversation through a wall. Perhaps it was a beacon that sweeps across the galaxy like a lighthouse, and we just happened to be in its path for one rotation. Perhaps the civilization that sent it had reasons for not repeating it that we cannot imagine. Or perhaps, and this is where our imagination can really take flight, the signal was connected to something else. Perhaps it was an announcement, a notification that something was happening, or about to happen. Perhaps it was related to the movement of objects through space, like comets falling from the Oort cloud. Perhaps it was a marker, a cosmic sign that said, "Pay attention to this region of space. Something interesting is coming." This brings us back to our wanderer, 3I Atlas. In 1977, when the WOW signal was detected, the comet was still in the outer solar system, invisible to our telescopes, unknown to humanity. But it was already on its way, following its long, slow spiral towards the sun. Could there be a connection? Not a direct causal connection, but something more subtle, more mysterious? The universe is full of patterns and connections that we don't yet understand. Quantum entanglement shows us that particles can be connected across vast distances in ways that seem to violate our intuitions about space and time. Dark matter and dark energy remind us that most of the universe is made of something we can't see and don't understand. Given how much we don't know, is it really so impossible that a comet and a radio signal could be related in some way? Perhaps the wow signal was not a message but a phenomenon, something that happens when certain conditions align in space. Perhaps when a comet of a certain composition at a certain distance from the Sun passes through a certain region of space, it can focus or amplify background radio emissions in unexpected ways. Perhaps 3I Atlas, or another comet on a similar trajectory, created the conditions necessary for the signal to be detected. This is pure speculation, of course. There's no scientific evidence for such a connection. But as we drift here in the darkness, contemplating these mysteries, speculation seems not only allowable but necessary. How else do we push the boundaries of knowledge except by wondering, by asking what if, by imagining possibilities that seem impossible until they're not? The Big Ear Radio Telescope continued to operate until 1997, when it was demolished to make way for a golf course. In its 30 years of operation, it detected many interesting signals, but nothing quite like the wow signal. That 72-second detection remains unique, unexplained, a question mark in our understanding of the universe. Today, SETI continues with more powerful telescopes and more sophisticated techniques. The Allen Telescope Array in California, the Green Bank Telescope in West Virginia, and many other instruments around the world continue to listen to the cosmos. They search millions of frequencies simultaneously, use advanced algorithms to filter out interference, and can detect much fainter signals than Big Ear ever could. But despite all these advances, we haven't detected another signal like the wow signal. We found pulsars, magnetars, and other exotic objects that produce strange radio emissions. We've detected fast radio bursts, mysterious millisecond flashes of radio energy from distant galaxies, but we haven't found anything that clearly says, we're here, we're intelligent, we want to communicate. The silence is sometimes called the Great Silence or the Fermi Paradox. If the universe is full of stars and many of those stars have planets, and some of those planets develop life, and some of that life becomes intelligent and technological, then where is everybody? Why haven't we detected clear signs of other civilizations? There are many proposed answers to this paradox. Perhaps life is incredibly rare. Perhaps intelligence is even rarer. Perhaps technological civilizations tend to destroy themselves before they can communicate across interstellar distances. Perhaps they're communicating in ways we haven't thought to look for. Or perhaps they're deliberately staying quiet, hiding from something we don't know about. The wow. Signal doesn't answer these questions, but it does suggest that we might not be listening in the right way, or at the right time, or for long enough. If signals like the wow signal are rare, one-time events, we might need to listen to the entire sky, all the time, at all frequencies, to have a chance of detecting them. That's a daunting task, but technology is making it increasingly possible. As you lie there, feeling the gentle pull of sleep, think about that August night in 1977. Somewhere in Ohio, a telescope was quietly listening to the cosmos. For 72 seconds, it heard something extraordinary. A signal from the stars, unexplained and unrepeated. At the same moment, people around the world were going about their lives, unaware that we might have just made contact with something beyond Earth. Children were playing, lovers were embracing, scientists were working in their labs, all under a sky that had just whispered a secret we couldn't quite hear. And somewhere in the outer solar system, a comet was continuing its ancient journey, carrying its cargo of ice and dust and organic molecules towards a distant rendezvous with the Sun. These two events, separated by vast distances and connected only in our imagination, remind us of how much we don't know about the universe we inhabit, They remind us that mystery is not a problem to be solved, but a gift to be treasured. They invite us to keep listening, keep watching, keep wondering. The signal in the silence, heard once and never again, continues to echo in our consciousness. It reminds us that the universe might be trying to tell us something, if only we knew how to listen. And perhaps, as we'll explore, the comets that visit us from the edge of the solar system might be part of that conversation, carrying messages we're only beginning to learn how to read. Now we must turn our attention to the comet itself, not just as a wandering piece of ice and rock, but as something potentially more profound. What if comets are not just passive objects, following the laws of gravity through space? What if they are active participants in some kind of cosmic communication system? What if the ice and dust they carry can somehow generate, amplify, or modulate radio signals? To explore this possibility, we need to understand what happens to a comet as it approaches the Sun, the remarkable transformations it undergoes, and the complex interactions between its material and the solar environment. When a comet like 3I Atlas begins its journey from the Oort cloud, it is essentially inert. The temperature is so close to absolute zero that all chemical and physical processes have essentially stopped. The various ices that make up the comet are as hard as rock. The dust and organic molecules embedded in the ice are locked in place, unchanging for billions of years. The comet is like a book with its pages frozen shut, its story unreadable. But as the comet falls inward and the Sun grows from a point of light to a disk, things begin to change. The first changes are subtle, almost imperceptible. The surface temperature rises from near absolute zero to perhaps 200 degrees Celsius. Still incredibly cold by Earth standards, but warm enough for the most volatile ices to begin to stir. The first ice to respond is usually carbon monoxide, which sublimes at extremely low temperatures. As the solid carbon monoxide turns directly into gas, it begins to carry away tiny particles of dust that were embedded in the ice. This is the beginning of the comet's coma, the fuzzy atmosphere that will eventually surround the nucleus. As the comet continues to approach the Sun, other ices begin to sublime. Carbon dioxide, methane, ammonia, and eventually water ice all begin to turn from solid to gas. Each of these substances sublimes at a different temperature, creating a complex sequence of activity as the comet warms. The process is not uniform across the comet's surface. The side facing the Sun warms faster than the dark side. Darker areas absorb more heat than lighter areas. Cracks and fissures in the ice allow gases to escape more easily in some places than others. This uneven heating and outgassing creates jets, fountains of gas and dust that erupt from specific points on the comet's surface. These jets can be powerful enough to actually change the comet's rotation, and even its orbit slightly. They're like natural rocket engines powered by the Sun's heat. From a distance, these jets merge together to form the coma, which can grow to be hundreds of thousands of kilometers across, larger than the planet Jupiter. But the coma is incredibly thin, less dense than the best vacuum we can create in laboratories on Earth. It's more like a glowing ghost than a substantial atmosphere. Now here's where things get interesting from a radio perspective. This coma is not just a cloud of neutral gas. The Sun's ultraviolet radiation ionizes many of the gas molecules, stripping away electrons and creating a plasma, a soup of charged particles. Plasmas have very interesting properties when it comes to electromagnetic radiation. They can absorb, emit, reflect, and refract radio waves in complex ways. They can act like lenses, focusing radio waves from distant sources. They can act like amplifiers, taking weak signals and making them stronger. They can even generate their own radio emissions through various mechanisms. One of the most intriguing aspects of cometary plasmas is their interaction with the solar wind. The solar wind is a stream of charged particles, mainly protons and electrons, flowing outward from the Sun at hundreds of kilometers per second. When this wind encounters the comet's plasma, it creates a shock wave, like the bow wave of a boat moving through water. This shock wave, called a bow shock, is a region of compressed, heated and turbulent plasma. In Earth's magnetosphere and around other planets, bow shocks are known to generate radio emissions. They can produce everything from low-frequency whistles to high-frequency bursts. Could a comet's bow shock produce radio emissions at specific frequencies, perhaps even at the hydrogen line frequency? The idea is not as far-fetched as it might seem. We know that comets contain vast amounts of hydrogen, both in the form of water ice and in other hydrogen-bearing molecules. As water ice sublimes and is broken apart by solar ultraviolet radiation, it releases huge amounts of hydrogen atoms. These atoms can be excited by various processes and then emit radiation as they return to their ground state. Under normal conditions, this emission is very weak and spread across many frequencies. But what if the conditions in a comet's coma and tail could create a natural maser? A maser is like a laser, but for microwave radiation instead of visible light. It's a process where radiation at a specific frequency is amplified through stimulated emission. Natural masers exist in space. We've detected them in the atmospheres of stars, in molecular clouds, and around certain types of galaxies. They require specific conditions, a population inversion, where more atoms are in an excited state than in the ground state, and some kind of pumping mechanism to maintain this inversion. Could the unique environment around a comet create such conditions? The solar radiation provides energy for pumping. The expansion of gases from the comet creates regions of different densities and temperatures. The magnetic fields carried by the solar wind and possibly generated by the comet itself could help organize and align particles. It's a complex system with many variables, and we're only beginning to understand how it all works. Every comet is different, with its own composition, its own pattern of outgassing, its own interaction with the solar environment. Some comets are rich in water ice, others in carbon dioxide or methane. Some have high dust-to-gas ratios, others are mostly gas. These differences could lead to very different electromagnetic behaviors. When we observe comets with radio telescopes, we do detect emissions, but they're usually thermal emissions from the dust or weak-line emissions from various molecules. We haven't detected anything like the "wow" signal from a comet, but perhaps we haven't been looking at the right time or in the right way or at the right comet. Consider the possibility that only certain comets, under certain conditions, can produce strong, narrow-band radio emissions. Perhaps it requires a specific composition, a specific size, a specific approach angle to the Sun. Perhaps it only happens during certain phases of the solar cycle, when the solar wind has particular properties. Perhaps it requires the comet to pass through a region of space with unusual magnetic or electric fields. If such emissions are rare and short-lived, we might simply have missed them. We don't continuously monitor every comet with radio telescopes. We usually observe them optically, studying their visible appearance and spectrum. Radio observations are less common and usually focus on specific scientific questions rather than searching for unexpected emissions. 3I Atlas was particularly interesting because of its composition and behavior. Spectroscopic observations showed that it was rich in carbon compounds, giving it a greenish tint. It was also producing large amounts of cyanogen and diatomic carbon, molecules that glow green when excited by sunlight. These molecules are interesting because they're relatively complex, requiring specific conditions to form and survive. The comet was also fragmenting as it approached the Sun, breaking into multiple pieces. This fragmentation would have exposed fresh ice to solar radiation, potentially triggering new and unusual outgassing patterns. Could the fragmentation of 3I Atlas have created conditions for unusual radio emissions? When a comet breaks apart, it releases enormous amounts of fresh material suddenly. The interior ice, which has been shielded from solar radiation, is suddenly exposed. This could create a burst of activity, a sudden increase in gas production and plasma generation. If the conditions were just right, could this burst include a strong radio emission? And here's a thought that connects back to our earlier speculation. What if the wow signal wasn't from 3i Atlas itself, but was somehow triggered by another comet, one that passed through the inner solar system in the 1970s. What if there's a class of comets that can produce such signals, and we've only detected one example so far? The more we learn about comets, the more complex and interesting they become. They're not just dirty snowballs as they were once described, they're dynamic, evolving systems with complex chemistry and physics. They're laboratories where we can study processes that don't occur naturally on Earth. They're time capsules that preserve information about the early solar system. And perhaps they're something more. Perhaps they're part of a natural communication system that we don't yet understand. This might sound like science fiction, but consider how many things in astronomy sounded like science fiction before they were discovered. Black holes, neutron stars, dark energy, exoplanets orbiting other stars. All of these were once considered too strange to be real. The universe has consistently proven to be stranger and more wonderful than we imagined. As you drift deeper into relaxation, imagine a comet not as a dead chunk of ice, but as a living, breathing entity. Not alive in a biological sense, but active, dynamic, responsive to its environment. Picture the jets of gas erupting from its surface like geysers, catching the sunlight and glowing with their own light. See the plasma tail stretching millions of kilometers behind it, a river of charged particles flowing away from the sun. Feel the electromagnetic field swirling around it, invisible but powerful, shaping the behavior of particles and waves. This is not a silent journey through space, but a symphony of physical processes, a dance of matter and energy. And perhaps, hidden within this symphony, there are notes we haven't learned to hear. Perhaps comets sing songs in radio frequencies, songs that are usually too faint or too brief for us to detect. Perhaps the wow signal was one note from such a song, caught by chance by a telescope that happened to be listening at just the right moment. Perhaps 3i Atlas, in its final approach to the Sun, and its ultimate fragmentation sang its own song, but we weren't listening in the right way to hear it. The idea that comets could be sources of intelligent-seeming radio signals challenges our assumptions about the nature of intelligence and communication. We tend to think of intelligence as biological, something that requires a brain, neurons, consciousness. We think of communication as intentional, directed, purposeful. But what if there are other forms of information transmission in the universe? What if the arrangement of molecules in a comet's ice encodes information in ways we don't recognize? What if the pattern of outgassing, the sequence of fragmentation, the spectrum of emissions, all carry meaning that we haven't learned to decode? This is not to suggest that comets are conscious or that they're trying to communicate with us. Rather, it's to open our minds to the possibility that information and meaning might exist in forms we haven't considered. The universe might be full of messages that we don't recognize as messages because they don't fit our preconceptions about what communication looks like. Think about how we encode information in our own technology. We use patterns of electromagnetic waves to carry television signals, cell phone calls, internet data. To someone who didn't understand our technology, these signals might seem like random noise. They would have no idea that the seemingly chaotic fluctuations in the electromagnetic fields actually carry pictures, sounds, and thoughts from one person to another. Could nature have its own encoding schemes? Could the complex chemistry of comets, the result of billions of years of cosmic processes, encode information about the history of the galaxy, the formation of solar systems, the conditions necessary for life? Could the radio emissions from comets, if they exist, carry this information in ways we haven't learned to decode? As we continue to study comets with increasingly sophisticated instruments, we're discovering more and more complexity. We're finding organic molecules we didn't expect, isotope ratios that tell stories about where and when the comet formed, and behaviors that challenge our models. Each new comet we study adds to our understanding, but also raises new questions. The European Space Agency's Rosetta mission which orbited and landed on Comet 67P Churyumov-Gerasimenko, revealed a world of unexpected complexity. The comet had cliffs and valleys, smooth plains and rough terrain. It had jets that turned on and off with the comet's rotation. It had organic molecules more complex than we expected, including glycine, an amino acid that is one of the building blocks of proteins. Rosetta also detected a kind of song from the comet, not in radio frequencies, but in magnetic field oscillations. The comet was generating oscillations in the magnetic field around it at frequencies below the range of human hearing. When these oscillations were sped up and converted to sound, they created an eerie, otherworldly melody. It wasn't a signal from an alien civilization, but it was a reminder that comets are more active and complex than we once thought. If comets can sing in magnetic fields, why not in radio waves? If they can carry amino acids, why not more complex messages? If they can survive journeys of millions of years, why not serve as messengers between distant parts of the galaxy? The connection between 3i Atlas and the WOW signal remains speculative, a possibility we can contemplate but not prove. But the very act of contemplating it opens our minds to the vastness of what we don't know. It reminds us that the universe is full of mysteries waiting to be discovered, connections waiting to be made, stories waiting to be told. Every comet that visits our inner solar system is a gift, a chance to learn something new about the cosmos and our place in it. Even when they break apart and fade away, like 3i Atlas did, they leave us with questions and wonder. As you continue to drift, feeling heavier and more relaxed with each breath, let the image of the comet's song stay with you. Not a song in the conventional sense, but a complex emission of matter and energy, a voice from the cosmic deep. Perhaps we haven't learned to hear it properly yet. Perhaps we need new instruments, new theories, new ways of thinking about communication and information. Perhaps the next comet that visits us will sing more clearly, or perhaps we'll finally learn how to tune our receivers to hear what has always been there. The cosmos is patient. It will keep sending us comets, keep presenting us with mysteries, keep inviting us to listen more carefully, think more creatively, wonder more deeply. And now, as we prepare to weave these two mysteries together more tightly, to explore the possibility of a connection that transcends our normal understanding of cause and effect, let yourself sink even deeper into relaxation. Feel the boundaries of your everyday concerns dissolving, like a comet's ice subliming into the vacuum of space. Let your mind become receptive to possibilities that might seem impossible in the harsh light of day, but feel perfectly natural in this gentle space between waking and sleeping. The comet and the signal, two mysteries separated by time and space, are about to converge in our imagination, creating new patterns of possibility. The time has come to weave together the threads we've been following separately. On one hand, we have a comet, 3i Atlas, a visitor from the Oort cloud that made its brief, dramatic appearance in our skies in 2020 before fragmenting and fading away. On the other hand, we have the WOW signal, a powerful radio emission detected in 1977 that has never been explained or detected again. These two events seem completely unconnected, separated by 43 years and vast distances in space. But what if there is a connection, something subtle and profound that we're only beginning to glimpse? Let's start by considering the trajectory of 3i Atlas. When astronomers first discovered it and calculated its orbit, they were able to trace its path backward in time. The comet follows a long elliptical orbit that takes it from the inner solar system out to the Oort cloud and back again. The period of this orbit is measured in thousands of years. Working backward from its 2020 appearance, we can ask, where was this comet in 1977 when the WOW signal was detected? The calculations show that in 1977, 3i Atlas was still in the outer solar system, somewhere beyond the orbit of Neptune, slowly falling toward the Sun. It was invisible to our telescopes then, too faint and too far away to detect. But it was there, and it was already on its way toward its eventual encounter with the inner solar system. Now, this might seem to rule out any connection. If the comet was so far away in 1977, how could it have had anything to do with a radio signal detected from a completely different direction in space? The wow! Signal came from the constellation Sagittarius, while the comet would have been in a different part of the sky entirely. They seem to have nothing to do with each other. But this is where we need to expand our thinking beyond simple direct connections. What if the relationship between the comet and the signal is not causal in the ordinary sense, but something more subtle, more quantum, more cosmic? Consider the possibility that comets, as they travel through space, interact with fields and forces that we don't fully understand. We know about gravity and electromagnetic fields. But what about the quantum fields that underlie all of reality? What about the dark matter that makes up most of the mass of the galaxy? What about dimensions of space-time that we can't directly perceive? Perhaps comets, with their unique composition and their long journeys through different regions of space, are sensitive to these hidden aspects of reality in ways we haven't recognized. Imagine that as 3I Atlas was passing through the outer solar system in 1977, it encountered something. Not a physical object, but a region of space with unusual properties. Perhaps a concentration of dark matter, or a fold in space-time, or a quantum field fluctuation. This encounter might have triggered something, a resonance, a vibration, an emission that propagated not through ordinary space but through some deeper level of reality. This emission might have emerged at a distant point in space, in the direction of Sagittarius, as the radio signal we detected. It's like plucking a guitar string at one end and hearing a note from the other end, except the guitar is the fabric of space-time itself, and the distance between the two ends is measured in light years. This might sound impossibly speculative, but consider what we've learned about quantum entanglement. Two particles can be connected in such a way that measuring one instantly affects the other, regardless of the distance between them. This spooky action at a distance, as Einstein called it, has been verified experimentally many times. If particles can be entangled, why not larger objects? Why not comets and regions of space? There's another possibility to consider. What if the wow signal was not a single emission from a single source, but the result of an alignment, a cosmic coincidence where multiple factors came together to create something extraordinary? Think of it like a cosmic lens. In gravitational lensing, the gravity of a massive object can bend light from a distant source, focusing it and making it appear brighter. What if something similar can happen with radio waves, but using mechanisms we don't yet understand? Perhaps in 1977, the position of 3I Atlas, combined with the positions of other objects in the solar system, created a kind of focusing effect. Maybe there was a weak, continuous radio source in the direction of Sagittarius, something natural like a pulsar or something artificial like a distant civilization's beacon. Under normal circumstances, this source would be too weak to detect. But for those 72 seconds in August 1977, the alignment was perfect, and the signal was focused and amplified to the point where Big Ear could detect it. The comet itself might have acted as one element in this cosmic lens. Its coma, even at that great distance from the Sun, would have contained ionized gas, a plasma that can interact with the electromagnetic radiation. If the geometry was just right, this plasma could have acted like a lens or amplifier, boosting the signal from the distant source. As the Earth rotated and the alignment changed, the effect would have disappeared, explaining why the signal lasted exactly as long as it took for the source to pass through Big Ear's beam. This cosmic lensing hypothesis could also explain why the signal has never been detected again. The alignment that created the focusing effect was unique, a once-in-a-lifetime or once-in-a-civilization coincidence. 3I Atlas continued on its orbit. Other objects in the solar system moved to new positions, and the cosmic lens dissolved. We could point our telescopes at the same region of sky forever and never detect the signal again, because the special conditions that made it detectable no longer exist. But let's go even deeper into speculation. What if comets are not just passive objects, but are somehow part of a vast natural information network that spans the galaxy? This is not to suggest that comets are artificial, or that they were designed by some intelligence. Rather, it's to consider the possibility that nature itself has mechanisms for encoding and transmitting information that we haven't discovered. Think about how DNA encodes information in biological systems. 4 simple molecules, arranged in different sequences, can encode all the complexity of life on Earth. The DNA molecule is remarkably stable, able to preserve information for thousands of years under the right conditions. It can be copied, transmitted, and read by biological machinery. It's a natural information storage and transmission system that emerged through evolution. Now imagine something similar but on a cosmic scale. The complex organic molecules found in comets could potentially encode information. Not genetic information, but something else. Perhaps information about the conditions in different parts of the galaxy, the chemical composition of different stellar systems, the history of cosmic events. This information might be encoded in the specific ratios of different molecules, the isotope patterns, the crystal structures of the ices. As comets travel between stellar systems, they could be carrying this information, like messages in bottles drifting across a cosmic ocean. When a comet approaches a star and begins to outgas, it might be broadcasting this information in the form of chemical emissions, dust patterns, and perhaps even radio signals. The wow! Signal might have been one such broadcast triggered by a comet we haven't identified, or by 3I Atlas through some mechanism involving time delay or quantum effects. The fact that it was at the hydrogen line frequency might not be a coincidence, but a natural consequence of the physics involved. Hydrogen is the most abundant element in the universe, and the hydrogen line is a fundamental frequency in astrophysics. If nature has a way of encoding information in electromagnetic radiation, the hydrogen line would be a logical frequency to use. This naturalistic explanation for the wow signal is different from the traditional CT hypothesis of an intentional signal from an alien civilization. It suggests that the universe might be full of information-carrying signals that are not intentional communications, but natural phenomena we don't yet understand. We might be surrounded by a cosmic conversation that we're only beginning to perceive. The fragmentation of 3I Atlas in 2020 adds another layer to this mystery. When a comet breaks apart, it's not just a mechanical fracturing. It's a complex process involving thermal stress, gas pressure, and possibly electromagnetic effects. The fresh ice exposed by the fragmentation would have very different properties from the processed surface layer. It might contain pristine material from the comet's formation billions of years ago. Could the fragmentation have released information that was locked in the comet's interior? Could it have triggered emissions that we didn't detect because we weren't looking for them? The Hubble Space Telescope observed the fragmentation, but it was looking at visible light, not radio waves. We don't know if anyone was monitoring the comet with radio telescopes during its breakup. There's a poetic symmetry to the idea that 3I Atlas might have been connected to the wow signal. The signal was a brief, unexplained emission that captured our imagination and has remained a mystery for decades. The comet was a brief, spectacular visitor that captured our attention and then dissolved before our eyes. Both events remind us of the transient nature of cosmic phenomena and the importance of being in the right place at the right time with the right instruments. They also remind us of how much we miss. For every comet we detect, how many pass through the inner solar system unseen? For every unusual signal we record, how many occur when we're not listening? The universe is vast and active, and we can only observe a tiny fraction of what's happening at any given moment. This brings us to a profound realization. The cosmos might be full of connections and patterns that we haven't recognized because we haven't been looking for them. We tend to study phenomena in isolation. Astronomers who study comets might not pay attention to radio signals. Radio astronomers might not consider the positions of comets. But what if the universe is more interconnected than we assume? What if events that seem unrelated are actually part of larger patterns that span vast distances and long time periods? The idea of cosmic connections is not new. Ancient astronomers believed that comets were omens, that their appearances were connected to events on Earth. We now know that comets don't cause plagues or the deaths of kings, but perhaps the ancients were onto something in a different way. Perhaps comets are connected to cosmic events, just not in the simplistic, superstitious way our ancestors imagined. Modern science is beginning to reveal some of these connections. We know that comet impacts have played a crucial role in the evolution of life on Earth, both in bringing water and organic molecules to our planet and in causing mass extinctions that change the course of evolution. We know that the solar system is not isolated, but is constantly interacting with the interstellar medium as it orbits around the galaxy. We know that cosmic rays from distant supernovae can affect cloud formation and climate on Earth. The more we learn, the more we realize that everything is connected in ways we're only beginning to understand. As you lie there, drifting deeper into relaxation, consider the possibility that you are part of these cosmic connections. The atoms in your body were forged in the hearts of stars that exploded billions of years ago. The water in your cells might have been delivered to Earth by comets like 3I Atlas. The organic molecules that make up your DNA have cousins in the ices of comets and the clouds between stars. You're not separate from the cosmos, but an integral part of it, connected to everything else through chains of cause and effect that stretch across space and time. When you look up at a comet in the night sky, you're not just seeing a visitor from the outer solar system. You're seeing a relative, a cosmic cousin made of the same star stuff as you. When we detect a mysterious radio signal from space, we're not just recording electromagnetic radiation. We're potentially hearing a voice in a cosmic conversation that includes us, even if we don't yet understand the language. The connection between 3I Atlas and the WOW signal, whether real or imagined, invites us to think differently about our place in the universe. We're not passive observers of cosmic events, but active participants in a grand, unfolding story. Every observation we make, every question we ask, every connection we hypothesize adds to our understanding and changes our relationship with the cosmos. Perhaps one day we'll discover that there really was a connection between the comet and the signal. Perhaps we'll develop new theories of physics that explain how such connections are possible. Perhaps we'll detect new signals that confirm or refute our speculations. Or perhaps the mystery will remain, a beautiful question mark that reminds us of how much we don't know. But even if we never find a definitive answer, the journey of exploration is valuable in itself. The act of wondering, of imagining possibilities, of looking for connections is what makes us human. It's what drives us to build telescopes and send spacecraft to comets. It's what inspires us to listen to the cosmos and dream of other intelligences among the stars. It's what brings us together in our shared curiosity and wonder. The WOW, Signal and 3I Atlas are more than just scientific mysteries. They're invitations to expand our consciousness, to think beyond the boundaries of what we know, to imagine a universe that is stranger and more wonderful than we can currently comprehend. They're reminders that we live in a cosmos full of surprises, where the next discovery might change everything we thought we knew. As we prepare to explore the broader implications of these ideas, let yourself sink even deeper into the peaceful darkness. Feel the boundaries between you and the universe becoming softer, more permeable. You are not just in the universe, you are of the universe. The same forces that guide comets and generate mysterious signals flow through you. The same atoms that make up distant stars make up your body. The same quantum fields that underlie all of reality underlie your consciousness. In this state of deep relaxation and openness, you can sense connections that are usually hidden by the noise and distraction of daily life. You can feel the subtle pull of gravity that connects you to every other mass in the universe. You can imagine the electromagnetic waves passing through you right now, carrying information from distant stars and galaxies, you can contemplate the possibility that consciousness itself might be a fundamental feature of the cosmos, not limited to biological brains, but present in some form throughout the universe. These are not scientific facts, but invitations to wonder, to expand your sense of what might be possible. In the gentle space between waking and sleeping, between knowledge and mystery, between self and cosmos, new insights can emerge. The connection between a comet and a signal, whether literal or metaphorical, becomes a doorway to deeper understanding, not just of the universe, but of your place within it. And as we continue our journey through these cosmic mysteries, remember that you are not just a passive listener, but an active participant in the great cosmic story. Your wondering, your questions, your dreams add to the collective human endeavor to understand the universe. Every time you look up at the night sky with curiosity, every time you ponder a mystery like the wow signal, every time you feel awe at the sight of a comet, you're participating in the same quest that has driven humanity since we first looked up at the stars and wondered what they were. The universe is speaking to us in countless ways, through comets and signals, through the dance of galaxies and the whisper of quantum fields. We're still learning the language, still developing our ability to listen and understand. But with each new discovery, each new connection we make, each new question we ask, we get a little closer to understanding the grand conversation of which we are a part. The journey continues, the mysteries deepen, and the wonder never ends. We have journeyed through the mysteries of a comet's path and a signal's enigma, and now we must widen our perspective even further. Beyond the specific mysteries of Three-Eye Atlas and the wow, signal lies a grander endeavor, one that represents perhaps humanity's most profound quest, the search for other minds in the cosmos, the patient listening for voices that might echo across the vast emptiness between stars. This is the story of SETI, the search for extraterrestrial intelligence, but it is also the story of humanity's deep need to know that we are not alone, that somewhere in this incomprehensibly vast universe, other beings might be looking up at their night sky and wondering the same things we wonder. The act of listening to the cosmos is, in its essence, an act of hope. Every time we point a radio telescope at the stars, every time we analyze a signal, every time we search for patterns in the cosmic static, we are expressing a fundamental belief that the universe might be inhabited by other conscious beings, other civilizations that have developed the technology to broadcast their presence across interstellar distances. It is a hope that transcends science, touching something deep in the human spirit, the part of us that has always looked at the stars and felt both small and connected to something infinitely larger than ourselves. The formal search for extraterrestrial intelligence began in 1960 when astronomer Frank Drake pointed a radio telescope at two nearby sun-like stars, Tau Ceti and Epsilon Eridani, and listened for any signs of artificial signals. He called it Project Ozma, after the princess in L. Frank Baum's Oz books, a character from a land far away and difficult to reach. For 2 months, Drake listened, but he heard only cosmic static, the natural radio emissions of the universe. Yet this apparent failure was actually a beginning. It demonstrated that the search was technically feasible, that we had the technology to detect signals from other civilizations if they were broadcasting with sufficient power. It inspired other astronomers to join the search, and it sparked a conversation about what we should be looking for and how we should be looking for it. Drake himself went on to formulate what became known as the Drake equation, a mathematical framework for estimating the number of communicating extraterrestrial civilizations in our galaxy. The equation considers factors like the rate of star formation, the fraction of stars with planets, the fraction of planets that could support life, the fraction where life actually develops, the fraction where intelligent life emerges, the fraction that develops technology capable of interstellar communication, and the length of time such civilizations remain detectable. Each factor in the equation is uncertain, some wildly so. We don't know how common life is in the universe. We don't know how often life develops intelligence. We don't know how long technological civilizations typically survive. Depending on the values you assign to these factors, the equation can suggest that the galaxy is teeming with communicating civilizations, or that we are utterly alone. This uncertainty is both frustrating and exciting. It means we don't know what we'll find, but it also means the possibilities are endless. The search for extraterrestrial intelligence has evolved dramatically since Drake's first attempt. Today, SETI researchers use some of the most powerful radio telescopes in the world, capable of monitoring millions of frequency channels simultaneously. They use sophisticated computer algorithms to filter out human-made interference and identify potentially interesting signals. They look not just for narrow band carriers like the WOW signal, but for any pattern that seems artificial rather than natural. The Allen Telescope Array in California, funded by Microsoft co-founder Paul Allen, consists of 42 radio dishes that work together as a single instrument. It can observe multiple star systems simultaneously, greatly increasing the efficiency of the search. The Breakthrough Listen project, funded by billionaire Yuri Milner, is using telescopes around the world to conduct the most comprehensive search for extraterrestrial intelligence ever undertaken. It's surveying 1 million nearby stars, the entire galactic plane, and 100 nearby galaxies, looking for any signs of technological activity. But SETI is not just about radio waves anymore. Researchers are also looking for other signs of extraterrestrial intelligence. They search for optical signals, brief flashes of laser light that might be used for interstellar communication. They look for infrared signatures that might indicate massive engineering projects, like Dyson spheres that capture a star's entire energy output. They search for atmospheric signatures on exoplanets that might indicate not just life, but technological modification of an entire world's atmosphere. The search has also become more nuanced in its assumptions about what extraterrestrial intelligence might look like and how it might behave. Early SETI efforts often assumed that alien civilizations would be somewhat like us, using radio waves for communication, broadcasting powerful beacons to announce their presence. But as our own technology has evolved, we've realized that these assumptions might be too narrow. Our own radio emissions are actually decreasing as we move from broadcast television and radio to cable, fiber optics, and directed satellite communications. An alien civilization observing Earth from a distance might have detected our radio emissions for only a brief window, perhaps a century or two before we went relatively quiet. If this pattern is common, it means the window for detecting a civilization through its radio leakage might be very short. This has led to new thinking about what kinds of signals we should be looking for. Perhaps instead of looking for intentional beacons or unintentional leakage, we should be looking for something else entirely. Perhaps we should be looking for the kinds of signals that an advanced civilization might use for its own purposes, signals that might be detectable across interstellar distances, even if they're not intended for us. Some researchers have suggested looking for evidence of massive engineering projects, things that would be visible across cosmic distances. A Dyson sphere, for example, would block some of a star's visible light while re-emitting the energy as infrared radiation. We could potentially detect such structures by looking for stars with unusual infrared excesses. Others have suggested looking for evidence of interstellar spacecraft. Perhaps antimatter engines that would produce characteristic gamma-ray signatures, or light sails that might create unusual optical effects as they pass between us and their host star. There's also growing interest in the idea of techno-signatures, any observable phenomenon that could only be produced by technology. This could include industrial pollutants in an exoplanet's atmosphere, unusual patterns of light that might indicate massive solar panel arrays, or even the waste heat from massive computational processes. The search for techno-signatures recognizes that we might not be able to understand or even recognize alien technology, but we might still be able to detect its effects on the environment. The connection to comets becomes interesting in this context. If comets can carry organic molecules between star systems, could they also carry other things? Could an advanced civilization use comets as a kind of interstellar postal service? embedding messages or even technology in cometary ice and sending them on trajectories that would eventually bring them to other star systems. It would be an incredibly slow form of communication, taking millions of years, but it would require no ongoing energy expenditure once the comet was on its way. This brings us back to our speculation about 3I Atlas and the WOW signal. What if some comets are not entirely natural? What if some of them have been modified or directed by intelligence? This doesn't mean the comets are artificial. Rather, it suggests that an advanced civilization might have learned to use natural objects for their own purposes. Just as we use rivers for transportation and wind for power, an advanced civilization might use comets for interstellar communication or transportation. The idea is not as far-fetched as it might seem. We already know that comets can be redirected. A relatively small change in a comet's velocity when it's far from the Sun can result in a large change in its trajectory. An advanced civilization could potentially catalogue millions of comets in their Oort cloud, calculate their future trajectories, and selectively nudge those that would eventually pass close to interesting star systems. They could even potentially embed information in the comet itself, not in any obvious technological way that would survive millions of years in space, but perhaps in the arrangement of molecules, the ratios of isotopes, or the distribution of organic compounds. The information might be encoded in a way that would only be detectable when the comet warms up and starts outgassing, releasing its contents in a specific pattern. The WOW signal might have been the result of such an encoding, a brief message released as some unknown comet passed through our solar system in the 1970s. Of course, this is pure speculation, but it illustrates how the search for extraterrestrial intelligence is expanding beyond traditional radio SETI. We're beginning to think more creatively about how intelligence might manifest itself in the universe, what traces it might leave, and how we might detect those traces. The search is also becoming more philosophical. We're questioning our assumptions about intelligence, consciousness, and communication. We're recognizing that our human perspective might be limiting our ability to recognize or understand extraterrestrial intelligence. What if intelligence can exist in forms we don't recognize? What if there are conscious entities made of dark matter, or living in the atmospheres of stars, or existing as patterns in the quantum vacuum? What if the universe is full of intelligence, but it's so different from us that we can't recognize it or communicate with it? These questions push the boundaries of science into philosophy and even spirituality. They force us to confront fundamental questions about the nature of consciousness, the meaning of intelligence, and our place in the cosmic order. The search for extraterrestrial intelligence is really a search for ourselves, for understanding what it means to be conscious, intelligent beings in a vast and mysterious universe. Every null result, every failure to detect a signal, tells us something. It might mean we're alone, but it might also mean we're looking in the wrong way, at the wrong frequencies with the wrong assumptions. The universe might be full of signals that we're not equipped to detect or understand. The cosmic airwaves might be full of conversations that we can't tune into because we don't know the frequency, the modulation, or the language. This is where the virtue of patience comes in. SETI is perhaps the most patient of all scientific endeavors. It's a search that might take centuries or millennia to succeed, if it ever does. Every day, researchers analyze data, knowing that they probably won't find anything, but also knowing that any day could be the day that changes everything. It's a kind of cosmic meditation, a practice of listening without expectation, of being open to surprise. The wow signal remains the most tantalizing hint that the search might one day succeed. Despite all the attempts to explain it as a natural phenomenon or human interference, it remains unexplained. It stands as a reminder that the universe can still surprise us, that there are phenomena we don't understand, that the next detection might be just around the corner. But even if we never detect another signal like the wow signal, even if we never make contact with another civilization, the search itself has value. It connects us to the cosmos in a profound way. It makes us think about our own civilization, our own future, our own place in the universe. It inspires us to be better, to survive longer, to become the kind of civilization that others might want to contact. The search for extraterrestrial intelligence also raises profound questions about what we would do if we succeeded. How would humanity react to definitive proof that we're not alone? How would it change our religions, our philosophies, our sense of ourselves? How would we respond to a message from the stars? Should we respond at all? These questions are not just academic. There are protocols in place for what to do if a signal is detected. The discoverer is supposed to verify the signal, rule out all possible sources of interference, and then notify the international astronomical community. The discovery should be announced to the world simultaneously, without any one nation or group claiming exclusive access to the information. Any response should be sent only after international consultation and agreement. But protocols are one thing. Reality might be quite another. The discovery of extraterrestrial intelligence would be the most significant event in human history. It would likely cause enormous social, political, and religious upheaval. Some people might react with fear, others with excitement, still others with denial. It would force us to reconsider everything we thought we knew about our place in the universe. Yet despite these potential challenges, the search continues. Thousands of people around the world are involved in SETI in various ways. Professional astronomers use sophisticated equipment to scan the skies. Amateur astronomers contribute their observations and analysis. Volunteers donate their computer processing power to analyze data through projects like SETI at Home. It's a collective human endeavor, a species-wide effort to answer one of our most profound questions. Are we alone? The involvement of comets in this search adds another layer of complexity and possibility. Every comet that visits our inner solar system is a potential carrier of information, whether natural or otherwise. Every unusual emission or behavior could be significant. The fact that we don't fully understand comets, that they can still surprise us with their complexity and behavior, means that they remain objects of both scientific interest and speculative possibility. As you lie there, drifting in the peaceful space between waking and sleeping, consider yourself part of this grand search. Every time you look up at the night sky with wonder, every time you contemplate the possibility of other life in the universe, you are participating in humanity's cosmic quest. You are adding your consciousness to the collective human effort to understand our place in the cosmos. The search for extraterrestrial intelligence is not just about finding others, it's about finding ourselves. It's about understanding what makes us unique and what connects us to the rest of the universe. It's about recognizing that we are part of a cosmic community, whether or not we ever make contact with other members of that community. The patience required for this search is itself a kind of wisdom. In our fast-paced, instant gratification world, SETI reminds us that some questions take time to answer. Some mysteries unfold over generations, centuries, or longer. The universe operates on timescales that dwarf human lifetimes, and if we want to understand it, we need to cultivate a patience that matches its scope. This patience is not passive waiting, but active listening. It's a state of openness and readiness, of being prepared for surprise while not being attached to any particular outcome. It's the same kind of patience that meditation cultivates, the ability to sit with uncertainty, to be comfortable with not knowing, to find peace in the question rather than requiring an answer. The cosmic listeners, those who dedicate their careers to SETI, embody this patience. They show up day after day, year after year, analyzing data, refining techniques, developing new strategies, all without any guarantee of success. They are like monks of science, devoted to a practice that might never yield the result they hope for, but finding meaning in the practice itself. And perhaps this is the real message of SETI, the real lesson it offers us. It's not about the destination, but the journey. It's not about finding extraterrestrial intelligence, but about what the search teaches us about ourselves. It's about recognizing our cosmic context, our connection to the universe, our responsibility as conscious beings who have developed the ability to listen to the cosmos and wonder about our place in it. The wow signal, whether it was from an alien civilization, a natural phenomenon, or something else entirely, succeeded in its most important function. It made us wonder. It reminded us that the universe is full of mysteries, that we don't have all the answers, that surprise is always possible. It inspired decades of additional searching, technological development, and philosophical reflection. In that sense, it doesn't matter whether the signal was real or not. Its effect on human consciousness was real and profound. Similarly, comets like 3I Atlas, whether or not they have any connection to extraterrestrial intelligence, serve as reminders of our cosmic heritage. They bring us material from the edge of the solar system, from the deep freeze of space, from the time before planets formed. They connect us to the larger story of the cosmos, the cycle of stellar birth and death, the slow aggregation of matter into worlds, the emergence of complexity from simplicity. Every comet is a messenger, whether or not it carries an intentional message. Every signal from space, whether natural or artificial, is information about the universe we inhabit. The art of cosmic listening is learning to hear all of these messages, to interpret them, to find meaning in them. It's about developing a sensitivity to the subtle voices of the cosmos, the whispers that are often drowned out by the noise of our daily lives. As we continue to develop new technologies, new ways of observing the universe, we expand our ability to listen. Radio telescopes become more sensitive, able to detect fainter signals from farther away. Optical telescopes become more powerful, able to see the atmospheres of planets orbiting other stars. Gravitational wave detectors open up an entirely new spectrum, allowing us to hear the universe in a way we never could before. Each new technology is like developing a new sense, a new way of perceiving reality. We are gradually becoming more aware of the rich, complex, multi-layered conversation that the universe is having with itself, and perhaps one day we'll discover that we've been part of this conversation all along, that consciousness itself is a fundamental feature of the cosmos, expressing itself in countless forms across space and time. The search for extraterrestrial intelligence might ultimately reveal that intelligence is not extraterrestrial at all, but universal, woven into the very fabric of reality. The boundaries we draw between ourselves and the cosmos, between Earth and space, between life and non-life, might turn out to be illusions, convenient categories that help us navigate our daily experience, but don't reflect the deeper unity of all things. This is the profound possibility that SETI points toward, even if it's not the stated goal of the scientific search. It's the possibility that we are not separate from the universe, but expressions of it, that intelligence is not a rare accident but a natural emergence, that consciousness is not confined to biological brains but is a fundamental feature of reality itself. These ideas take us beyond science into philosophy and spirituality, but they emerge naturally from contemplating the questions that SETI raises. If we are listening for intelligence in the cosmos, we must first understand what intelligence is. If we are searching for consciousness among the stars, we must first understand the nature of consciousness itself. The patient listening of SETI becomes a form of meditation, a practice of expanding our awareness beyond the narrow confines of our individual perspectives. It's a reminder that we are part of something infinitely larger than ourselves, something that includes not just other possible civilizations, but the entire cosmic process of which we are a part. And as we drift deeper into this contemplation, feeling the boundaries of our individual consciousness softening and expanding, we can begin to sense the deeper connections that unite all things. The atoms in our bodies, forged in the hearts of stars, the water in our cells, possibly delivered by comets, the organic molecules that make up our DNA, cousins to the molecules found in interstellar space. We are not observers of the cosmos. We are participants in it, expressions of it, ways that the universe is coming to know itself. Now we must venture into even deeper waters, into questions that push the boundaries of science and philosophy. If there is a connection between comets and signals, between 3i Atlas and the WOW signal. What might that mean for our understanding of the universe and our place within it? What if the cosmos is not the cold, indifferent void that modern science sometimes portrays, but something far more interconnected, far more alive with possibility than we have dared to imagine? Let us explore these implications not with the certainty of answers, but with the openness of wonder, allowing ourselves to dream of possibilities that might seem impossible in the harsh light of day, but feel mysteriously plausible in this gentle space between sleeping and waking. Consider first the implications for our understanding of information and communication in the universe. We tend to think of information as something that requires a sender and a receiver, a message encoded and then decoded. But what if information can exist in more subtle forms? What if the universe itself is constantly encoding and transmitting information in ways we haven't recognized? The arrangement of matter in a comet's nucleus might encode information about the conditions in the early solar system. The pattern of outgassing as the comet approaches the sun might encode information about its composition and history. The interaction between the comet's plasma tail and the solar wind might generate electromagnetic signals that encode information about both the comet and the solar environment. If we expand this thinking, we might begin to see the entire universe as an information processing system. Every particle interaction, every gravitational wave, every photon of light carries information. The universe is constantly computing, constantly processing, constantly communicating with itself. In this view, comets become not just carriers of physical material, but carriers of information. They are like packets of data traveling through the cosmic internet, carrying messages we haven't learned to read. The WOW signal might have been one such message, briefly readable as it passed through our detection system, like a fragment of an encrypted file that momentarily decoded itself. This perspective has profound implications for how we think about consciousness and intelligence. If the universe is fundamentally information-based, then consciousness might not be limited to biological systems. It might be a more general property of information processing systems, emerging whenever information is integrated in sufficiently complex ways. A comet, with its complex chemistry and its dynamic interaction with its environment, might have a form of consciousness so different from ours that we don't recognize it as consciousness at all. This is not to say that comets are thinking or feeling in any way we would understand. Rather, it's to suggest that consciousness might exist on a spectrum, from the simple information integration of elementary particles to the complex self-awareness of human beings, with many intermediate forms we haven't imagined. The connection between 3i Atlas and the WOW signal, if it exists, might represent a form of cosmic consciousness expressing itself. Not a deliberate message from one conscious entity to another, but a natural expression of the universe's inherent tendency toward complexity, pattern formation, and information exchange. This view aligns with certain interpretations of quantum mechanics, which suggest that consciousness plays a fundamental role in the collapse of the wave function, in the transition from quantum possibility to classical actuality. If consciousness is fundamental to the universe, then every observation, every measurement, every interaction might be a form of cosmic consciousness expressing itself. In this framework, our search for extraterrestrial intelligence becomes part of the universe's search for itself. We are the universe's way of looking for other parts of itself that have developed self-awareness. The radio telescopes we build are like neurons in a cosmic brain, reaching out to make connections with other neurons. The signals we detect or fail to detect are like synaptic transmissions, successful or unsuccessful attempts at cosmic communication. This perspective also has implications for how we think about time and causality. In our everyday experience, causes precede effects, and information flows from past to future. But quantum mechanics hints at more complex relationships, where future events can influence past measurements, where particles can be entangled across space and time in ways that defy our classical intuitions. What if the WOW signal in 1977 and the appearance of 3i Atlas in 2020 are entangled events, connected not through classical causality, but through quantum correlations that transcend our normal understanding of space and time. What if the signal was not a precursor to the comet, but a kind of echo, a resonance between two events that are connected in the deeper structure of reality? This might sound like science fiction, but it's grounded in real physics. Quantum entanglement is real. Retrocausality, while controversial, is seriously discussed by physicists. The universe is far stranger than our everyday experience suggests, and connections that seem impossible might actually be fundamental features of reality. If we accept the possibility of such connections, it changes how we think about prediction and prophecy. Throughout history, humans have reported premonitions, visions of future events, dreams that seem to come true. Science typically dismisses these as coincidence, selective memory, or fraud. But what if some of these experiences represent genuine perception of quantum correlations, brief glimpses of the deeper connections that unite all things? The appearance of comets has long been associated with prophecy and omens. Ancient cultures saw them as messages from the gods, warnings of impending change. We now explain comets scientifically, but perhaps the ancients were perceiving something real, even if they didn't understand the mechanism. Perhaps sensitive individuals can sometimes detect the subtle correlations between cosmic events, feeling the approach of a comet years before it becomes visible, sensing the resonances that connect celestial mechanics to terrestrial events. This is not to validate superstition or to suggest that comets control human destiny. Rather, it's to propose that the universe might be more deeply interconnected than we realize, that events separated by vast distances and long times might be correlated in ways our current science doesn't fully understand. The implications extend to our understanding of life itself. We know that comets carry organic molecules, the building blocks of life. We know that comet impacts have delivered water, and possibly even primitive life to Earth. But what if the connection between comets and life is even deeper? What if life is not a rare accident, but a fundamental tendency of the universe, encoded in the very laws of physics? What if the organic molecules in comets are not random assemblages, but expressions of this tendency? Seeds of complexity that naturally emerge wherever conditions allow? What if the universe is not just capable of supporting life, but actively generates it, distributes it, nurtures it through mechanisms we're only beginning to understand? In this view, comets become agents of cosmic evolution, carrying not just the materials for life, but the information patterns that guide life's development. Each comet might carry a slightly different version of this information, leading to the vast diversity of life we see on Earth and might find elsewhere in the universe. The wow signal might have been related to this process in ways we can't yet fathom. Perhaps it was a burst of information related to life's encoding, a cosmic DNA transmission that we detected but couldn't decode. Perhaps it was connected to the approach of comets carrying particularly significant organic cargo. Perhaps it was the universe announcing a new phase in the evolution of complexity and consciousness. These ideas take us to the edge of current scientific understanding and beyond. They require us to think differently about fundamental concepts like information, consciousness, causality, and life. They challenge the materialist paradigm that has dominated science for centuries and suggest a universe that is more alive, more conscious, more purposeful than we have assumed. But even if these specific speculations prove incorrect, they serve an important purpose. They expand our thinking, challenge our assumptions, and open us to possibilities we might otherwise dismiss. They remind us that the universe is far stranger and more wonderful than we know. That mystery is not a problem to be solved, but a gift to be treasured. They invite us to approach the cosmos with humility and wonder, rather than arrogance and certainty. The connection between 3 Atlas and the wow signal, whether real or imagined, becomes a koan, a puzzle that breaks us out of our conventional thinking and opens us to deeper truths. Like the Zen student contemplating the sound of one hand clapping, We contemplate the meaning of a comet and a signal, seemingly unconnected yet somehow resonant in our consciousness. As you drift deeper into relaxation, let these possibilities wash over you like gentle waves. You don't need to believe them or disbelieve them. Simply let them exist in your awareness, expanding your sense of what might be possible. Feel how your individual consciousness might be part of a larger cosmic consciousness, how your thoughts and dreams might be connected to the movement of comets and the transmission of signals across space. Consider that every time you wonder about the universe, you are the universe wondering about itself. Every question you ask is the cosmos questioning its own nature. Every moment of awe you experience is the universe being awed by its own beauty and complexity. This is the deeper meaning of our cosmic journey tonight. It's not just about comets and signals, but about recognizing our profound connection to all things. It's about understanding that we are not separate from the mysteries we contemplate, but part of them, expressions of them, ways that the mystery is exploring itself. The implications ripple outward, touching every aspect of our existence. If we are truly connected to the cosmos in these deep ways, then our actions matter on a cosmic scale. The choices we make, the thoughts we think, the love we share all contribute to the cosmic conversation. We are not insignificant specks in an indifferent universe, but active participants in a cosmic evolution toward greater complexity, consciousness, and connection. This perspective brings both responsibility and hope. Responsibility because we recognize that we are shapers of cosmic destiny, that our species' survival and evolution matter not just to us, but to the universe itself. Hope because we realize we are not alone, even if we never detect another technological civilization. We are part of a cosmic community that includes not just potential aliens, but comets and stars, planets and galaxies, all participating in the same grand adventure of existence. The search for connections between phenomena like comets and signals becomes a spiritual practice, a way of recognizing and strengthening our cosmic connections. Each mystery we contemplate, each pattern we perceive, each moment of wonder we experience adds to the collective consciousness of the universe. As we prepare to conclude our journey, to bring together all the threads we've been weaving, feel how your consciousness has expanded through this contemplation. You started by considering a comet and a signal, two discrete events separated by time and space. But through patient exploration, through allowing yourself to wonder and speculate, you've discovered connections that run deeper than surface appearances. You've glimpsed the possibility that everything is connected, that the universe is not a collection of separate objects, but a unified whole expressing itself in countless forms. This is the gift of mystery, the beauty of the unknown. It invites us to expand beyond our limited perspectives, to embrace uncertainty as an opportunity for growth, to find peace in questions rather than requiring answers. The universe keeps its deepest secrets not to frustrate us, but to inspire us, to keep us wondering, growing, evolving toward ever greater understanding and connection. And now, as we approach the end of our cosmic meditation, we must gather all these threads together, weaving them into a final tapestry of wonder. We must return from the vast reaches of space and time to the quiet moment of now, bringing with us the expanded awareness we've cultivated. We must consider what it means to live with mystery, to embrace the unknown, to find beauty in questions that may never be answered. The journey we've taken tonight, from a comet's silent approach to a signal's brief cry to the vast implications of their potential connection, has been more than an intellectual exercise. It has been an invitation to see the universe and ourselves in a new way, to recognize that we are part of an ongoing cosmic story whose ending has not yet been written. We return now to the essential question that has guided our journey. What if there is a connection between 3 Atlas and the WOW signal? Not to answer it definitively, for that is beyond our current knowledge, but to appreciate what the question itself offers us. It is a doorway into wonder, an invitation to see the universe not as a collection of isolated phenomena, but as a vast, interconnected web of relationships and resonances. The beauty lies not in knowing, but in wondering, not in answers, but in the quality of our questions. Think back to where we began, with the image of a comet falling slowly through space, a journey of millions of years culminating in a brief, bright appearance in our skies. 3 Atlas travelled from the incomprehensible darkness of the Oort cloud, carrying within its frozen heart the pristine materials of our solar system's birth. It was a messenger from the deep past, a time capsule from an era before Earth existed, before life emerged, before consciousness dawned. As it approached the sun, this ancient ice began to sublime, releasing gases and dust that had been locked away for billions of years. The comet developed its ethereal coma, its graceful tails streaming away from the sun like cosmic hair in a stellar wind. For a brief moment it was visible to us, a faint smudge in our telescopes, a reminder of the vast cold spaces that surround our warm living world, and then, as the sun's heat and gravity stressed its fragile structure, 3I Atlas began to fragment. The single nucleus broke into pieces, each continuing on the same path but no longer united. It was dissolution and transformation simultaneously, an ending that was also a beginning. The materials that made up the comet were not destroyed but dispersed, returned to the solar system to participate in new cycles of aggregation and creation. Perhaps some of the dust from 3I Atlas will eventually fall to Earth, adding its ancient materials to our world's inventory. Perhaps some of the organic molecules it carried will contribute to the ongoing chemical evolution of our planet. Perhaps, in ways we cannot fathom, its passage through our solar system has altered the course of cosmic evolution, creating ripples that will propagate through space and time. Now think of the WOW signal, that enigmatic transmission detected on a summer night in 1977. For 72 seconds, a radio telescope in Ohio heard something extraordinary, a narrow band signal at the hydrogen line frequency, rising and falling in intensity exactly as expected from a distant cosmic source. It was powerful, focused, and unlike anything detected before or since. It remains unexplained, a question mark in our understanding of the universe, a reminder that there are phenomena beyond our current comprehension. The signal lasted just long enough to be recorded, just long enough to be noticed, but not long enough to be verified or decoded. It was like a cosmic whisper, heard once, and then lost in the vast silence of space. Was it a message, a beacon, a natural phenomenon we don't understand? Or was it something else entirely, a glimpse of cosmic processes that transcend our simple categories of natural and artificial? The mystery of the WOW signal has inspired decades of searching, thousands of hours of telescope time, countless hypotheses and speculations. It has become a symbol of our quest to understand our place in the universe, our hope that we are not alone, our willingness to listen patiently to the cosmos even when it seems silent. It represents the best of human curiosity and persistence, our refusal to give up on the possibility of cosmic connection. When we consider these two phenomena together, the comet and the signal, we are not trying to force a connection where none exists. Rather, we are exploring the possibility that the universe is more interconnected than we typically assume. We are entertaining the idea that events separated by vast distances and long times might be related in ways our current science doesn't fully understand. Perhaps the connection is physical, involving mechanisms of physics we haven't discovered yet. Perhaps it's informational, with both phenomena encoding or transmitting information in ways we haven't learned to decode. Perhaps it's consciousness-based, representing expressions of a cosmic awareness that transcends individual objects and events. Or perhaps the connection exists only in our minds, in our human tendency to see patterns and relationships. But even this is significant. Our ability to perceive connections, to wonder about relationships, to imagine possibilities beyond the immediately apparent, is itself a cosmic phenomenon. We are the universe developing the capacity to contemplate itself, to see patterns in its own behavior, to wonder about its own nature. The question, what if 3i Atlas connects to the wow signal, becomes a mirror in which we see reflected our own cosmic nature. We are pattern seekers, meaning makers, connection weavers. We are the universe's way of connecting dots, of finding relationships, of creating stories that give meaning to existence. Whether or not there is an objective connection between the comet and the signal, our contemplation of the possibility is itself meaningful, itself a form of cosmic self-awareness. This brings us to a profound realization. The universe is not just something we observe, but something we participate in creating. Through our observations, our questions, our wonderings, we add to the universe's complexity and self-awareness. We are not passive recipients of cosmic information, but active participants in cosmic evolution. Every time we look through a telescope, we are the universe observing itself. Every time we detect a signal or track a comet, we are the universe keeping track of its own processes. Every time we wonder about connections and possibilities, we are the universe expanding its own consciousness. This participatory view of cosmology suggests that consciousness and cosmos are not separate, but intimately intertwined. The universe is not a stage on which consciousness performs, but a living system of which consciousness is an integral part. Comets and signals, stars and planets, life and intelligence are all expressions of this living system, all ways that the cosmos manifests its inherent creativity and complexity. In this view, the search for extraterrestrial intelligence becomes something more than looking for other technological civilizations. It becomes the universe's search for its own distributed intelligence, its attempt to connect its various conscious components into a greater whole. Whether we ever detect signals from other civilizations or not, we are participating in this cosmic awakening simply by searching, by wondering, by remaining open to possibility. The beauty of the unknown, the title and theme of our final contemplation, is not about ignorance or uncertainty, but about potential and possibility. The unknown is not empty, but full, pregnant with infinite possibilities waiting to be actualized. Every mystery we encounter, every question we cannot answer, is an invitation to growth, to expansion, to evolution. Consider how much we have learned in just the past century. We've discovered that the universe is expanding, that it began in a big bang, that it's filled with dark matter and dark energy we don't understand. We've found thousands of planets orbiting other stars, detected gravitational waves from colliding black holes, and landed robots on Mars. Each discovery has raised new questions, revealed new mysteries, opened new frontiers of the unknown. The unknown is not shrinking, but expanding. The more we learn, the more we realize we don't know. This is not a failure of science, but its greatest success. It means the universe is inexhaustibly rich, infinitely creative, endlessly surprising. We will never run out of wonders to discover, mysteries to contemplate, questions to ask. 3. Atlas and the wow signal represent this beautiful unknown. They are reminders that despite all our knowledge and technology, the universe can still surprise us. A comet can appear and fragment in unexpected ways. A signal can be detected that defies explanation. These events keep us humble, curious, and open to wonder. They prevent us from becoming too certain, too closed, too convinced that we understand how everything works. Living with mystery requires a certain kind of courage. It's easier to have answers, even wrong answers, than to live with open questions. It's more comfortable to believe we understand the universe than to acknowledge the vast depths of our ignorance. But mystery is not our enemy. It's our teacher, our inspiration, our invitation to grow. When we embrace the unknown, we embrace possibility. We acknowledge that the future is open, that new discoveries await, that transformations we cannot imagine are possible. we align ourselves with the creative principle of the universe itself, the force that brings forth new forms, new patterns, new expressions of complexity and consciousness. This is the gift that 3i Atlas gave us in its brief appearance and dissolution. It reminded us that the cosmos is dynamic, that things change, that what seems permanent can fragment and transform. It showed us that even after billions of years of frozen stability, new chapters can begin, new stories can unfold. The comet's journey from the Oort cloud to the sun and back is a metaphor for all cosmic journeys, including our own. We too have emerged from cosmic darkness, warmed by stellar fire, and will eventually return to the cosmic commons from which we came. The wow signal offers a different gift, the gift of persistent mystery. After decades of analysis and speculation, it remains unexplained. It stands as a monument to the unknown, a reminder that not everything can be easily categorized or understood. It challenges us to remain open, to keep listening, to maintain hope even in the face of silence. It suggests that the universe might speak to us in ways we don't expect, at times we don't anticipate, in languages we don't yet understand. Together, the comet and the signal teach us about time and patience. The comet's journey took millions of years. The signal lasted 72 seconds. Yet both are part of the same cosmic story, the same unfolding of possibility in time. They remind us that the universe operates on many timescales simultaneously, from the quantum fluctuations that happen in fractions of a second to the stellar evolution that takes billions of years. Our human lives occupy just a tiny slice of this temporal spectrum. Yet we have the remarkable ability to contemplate times far beyond our direct experience. We can imagine the deep past when comets formed, and the deep future when they will return. We can wonder about signals sent millions of years ago from distant civilizations, and signals we might send that won't be received for millions of years to come. This temporal awareness is both humbling and empowering. It reminds us of our mortality, our brief moment in the cosmic dance. But it also connects us to the eternal, to processes and patterns that transcend individual lives and even entire civilizations. We are temporary expressions of something permanent, finite manifestations of the infinite. As you lie there, feeling the weight of your body, the rhythm of your breath, the quiet pulse of your heart, you're experiencing the universe from one unique perspective. No one else in all of space and time will ever have exactly your experience, your thoughts, your dreams. You're irreplaceable, a unique node in the cosmic network of consciousness. Yet you're also connected to everything else. The atoms in your body have been part of countless other forms before they were you. They've been in stars and planets, in oceans and mountains, in other living beings. After you're gone, they'll continue their journey, participating in new forms, new experiences, new expressions of cosmic creativity. This is the ultimate beauty of the unknown. It assures us that the story continues. Our individual chapters may end, but the book goes on. New characters appear, new plots develop, new mysteries emerge. The universe continues its creative exploration, its journey toward ever greater complexity and consciousness. The possible connection between 3i Atlas and the wow signal, whether it exists in physical reality or only in our imagination, has served its purpose. It has taken us on a journey through space and time, through science and speculation, through knowledge and mystery. It has expanded our awareness, challenged our assumptions, and opened us to wonder. We may never know if there was a real connection between the comet and the signal, but in contemplating the possibility, we have discovered real connections between Earth and space, between past and future, between the known and unknown, between ourselves and the cosmos. We have remembered that we are not separate from the universe but expressions of it, ways that it is coming to know itself. As our journey together draws to a close, let the sense of wonder remain. Let the questions stay open. Let the mystery be a companion rather than a problem. The universe is vast and strange and beautiful, and we are part of its vastness, its strangeness, its beauty. Every night, comets are falling through space, most of them unseen. Every moment, signals are crossing the cosmos, most of them undetected. Every instant, the universe is creating new patterns, new possibilities, new expressions of its infinite creativity. We are witnesses to this cosmic creativity, but more than that, we are participants in it. Through our consciousness, our curiosity, our capacity for wonder, we add to the universe's richness. We are the universe becoming aware of itself, contemplating itself, wondering at itself. The comet dissolves, but its materials continue in new forms. The signal fades, but its mystery continues to inspire. Our individual lives end, but the cosmic journey continues. And in the continuing, in the endless unfolding of possibility, in the eternal dance of known and unknown, there is a beauty that transcends understanding. This is the beauty of the unknowing, the gift of mystery, the grace of questions without answers. It keeps us young in spirit, open in mind, humble in heart. It connects us to the child who first looked up at the stars in wonder, and to the future beings who will look up at stars we cannot imagine, wondering things we cannot conceive. The universe whispers its secrets in the language of comets and signals, in the poetry of physics and the mathematics of mystery. We are still learning to listen, still learning to translate, still learning to understand. But perhaps understanding is not the goal. Perhaps the goal is simply to remain open, to keep wondering, to continue the conversation. As you drift now towards sleep or back toward waking, carry with you this sense of cosmic connection. Remember that you are made of star stuff, that you are a way the universe is knowing itself, that your wonder adds to the sum of cosmic consciousness. The mysteries remain, beautiful and beckoning. The questions continue, deep and nourishing. The journey goes on, through space and time, through knowledge and unknowing, through the finite and the infinite. You are part of this journey, this mystery, this beauty. You always have been, and you always will be in one form or another, in one state or another, part of the eternal cosmic dance. The comet continues its journey through space. The signal continues to echo in our consciousness, and we continue to wonder, to question, to dream of connections and possibilities. This is our gift, our purpose, our cosmic role. To be the universe wondering at itself, to be the mystery contemplating itself, to be the question that contains its own answer in the beauty of the asking. Rest now in this beauty, this mystery, this wonder. Let the boundaries dissolve between you and the cosmos, between question and answer, between known and unknown. You are home in the universe, and the universe is home in you. The journey continues, but for now, for this moment, you can rest in the beauty of not knowing, in the peace of mystery, in the gentle embrace of cosmic wonder.